Okay, so we'll start slowly. Okay, so let him join together. So today we are going to see 571 damage mechanism. So some questions said this is the second most important code. So the first important code is 570. So 50% of the question will be asked from the 570. But some questions generally it will have around 10 to 15 questions, the standard question set. But last year, some new set question they have more than 20 questions in 570. Okay, 571. So it is a very important code. First, how to understand the damage mechanism. It is not an easy code actually. It is a little bit tough code actually. Now, when you go for a in-service inspection, what is your 570 certification? It talks about the in-service inspection of the process piping. So what are the different type of inspection we have in a piping? In the large pipe, we can go inside and check. That is called internal piping. Generally, internal inspection is not carried out on the piping because the size is small. The next one is called the external inspection. External inspection means internal inspection means checking the inside condition from inside, which is practically not possible for most of the piping. Only large diameter piping we can go inside. Second one is the external inspection, checking the outside condition from outside without NDT. So there will be no NDT actually. So what they will do in the external inspection, support condition, foundation condition, painting condition, or the insulation condition, whether pipe is vibrating, pipe is leaking, misalignment. This all we can check in the external inspection. We can use some mechanical tools, but we will not use NDT. The third one is on-stream. On-stream means checking the inside condition from the outside. How we will check the inside condition from the outside? By NDT. So what are the generally preferred NDT methods for the on-stream inspection is RT and the UT. UT we can go at RT, some particular diameter we can go RT also. Apart from that, we have CUI, corrosion under insulation inspection. Then we have a what you call CML inspection. Many type of inspection are there. But when you are going for any type of this inspection, first you should know what you are going to look at, what you are looking for. So you should have a idea about the damage mechanism. So what type of damage mechanism will come in a particular pipe? It depends on the what service it is operating. What is the design condition? Design condition means material, thickness, pressure, temperature. Based on this, we should first expect where the problem will come and what NDT will detect all these things. Okay. Now, first, we have, it is not the entire 571 book. Entire 571 book, we have 65 damage mechanisms. But this is 15 damage mechanism related to the process piping. So from this only question will be asked. As per 570, damage mechanism can be classified into 6 groups. The first group is called metal loss. Metal loss means all forms of corrosion. Any corrosion will result in a metal loss. So what are the forms of corrosion we have? You can see here, atmospheric corrosion. This is crack, leave it. Atmospheric corrosion, sorry. Atmospheric corrosion, caustic corrosion, then corrosion under insulation, erosion corrosion, galvanic corrosion, hydrochloric acid corrosion, microbiology influenced corrosion, soil corrosion, sulfide. Sulfide also form of corrosion. The other things all will have the word corrosion. Apart from the corrosion, sulfidation is also a form of corrosion. In if a very, very important, many exam this question is asked. Above what temperature sulfidation will come? 500 degree Fahrenheit. Why I said that the damage mechanism is a little bit tough code, because you have to remember some 10 to 15 temperatures. Materials you have to remember. Okay, because many questions will be in closed book also. Okay. So sulfidation is a high temperature corrosion. What temperature it will happen? Above 500 degrees Fahrenheit. So this is corrosion, first group. The second group is a surface cracks. So which type of cracks will come on the surface? All fatigue cracks are surface cracks. So first you should know what is meant by fatigue. Fatigue means cyclic loading. Cyclic loading, I told you there is one word, integrity operating window. Suppose your pressure is operating pressure 100 psi, a small range is allowed to fluctuate. If it is excessively fluctuating, then it is called cyclic loading. So all fatigue cracks are surface crack. What fatigue crack we have here? We have mechanical fatigue and vibration induced fatigue. There are other two fatigues which is not part of our exam is thermal fatigue due to temperature fluctuation. Then another one is corrosion fatigue also. So for us, we have mechanical fatigue. Now vibration also included in the mechanical fatigue. And the second one is all environmental cracks are surface cracks. So what is mean by environmental crack? Environmental cracks, stress corrosion cracks, both are same. Why they are called as environment cracks? Because the corrosion is provided by the service environment, the chemical. And if it is stress, where there will be stress in a joint when it is not PW steel. Any non-PW steel weld will have a residual stress. When stress and corrosion combine, it will crack it during service. That is called a stress corrosion cracks. So we have for our exam, amine stress corrosion cracking, then caustic stress corrosion cracking, chloride stress corrosion cracking. 3 stress corrosion cracks. So this is the second group. Again, I will repeat. First group, metal loss, all forms of corrosion plus sulfidation. Second group, surface cracks, all cyclic fatigue cracks and stress corrosion cracks. Surface crack. Third one is the subsurface cracks. Subsurface crack means inside the pipe it is cracking. Wherever hydrogen involved, it will be a subsurface crack, but we don't have any damage mechanism hydrogen related in this list. That is the third group. So all hydrogen related cracks are subsurface crack. I am talking about the 570 classification. 571. Fourth one is metallurgical change. What is meant by metallurgical change? No corrosion, no crack. It is breaking into pieces. It becomes fracture. So temper embrittlement, hydrogen embrittlement, graphitization. These are metallurgical change. Again, not in the list. Fifth one is called blisters. Blisters are another small projections. Hydrogen blisters, again not in the list because piping blister generally will not come. It is a pressure vessel related problem. Then sixth one is high temperature problem. High temperature, there is one thing called high temperature hydrogen attack. Another one is called creep or stress rupture. That also not in the list. Okay. So actually we have only corrosion, surface cracks, and some, that's all, only two damage mechanism, two types we have. Other types is not part of our exam. But as per 570, after that we are going to 570 class. 570 we have 6 type of damage mechanism. So I am covering in advance. Now, how to understand the damage mechanism? The first thing you should know, what is the meaning of the particular word? Brief description of the damage. For example, amine stress corrosion cracking. What is amine stress corrosion cracking mean? So what the answer the code says? When amine service, in service we have a amine and a non-PWCD weld, there is a corrosion, it will result in a crack. That is called amine stress corrosion crack. Surface crack caused by amine when contacting a non-PWCD weld, that is a amine stress corrosion. So for each damage mechanism, we have brief description you should know. Second one is affected material. Which material damage mechanism will affect? Some damage mechanism will affect all materials. Exam, they will not ask. Any damage mechanism is affecting all materials, they will not ask in the exam. Some damage mechanism will affect only particular materials. For example, amine stress corrosion cracking, it will come only in carbon and low elastic. It will not come in a stainless steel. Okay. If you take atmospheric corrosion, again it is a carbon steel, low elastic related problem. Stainless steel, it will not come. Caustic corrosion, it can come stainless steel also. Caustic stress corrosion cracking, it can come stainless. Reverse, chloride stress corrosion cracking will come only in stainless. It will not come in carbon and low elastic. So you have to see, I used to tell before exam, only 2 code books you have to read repeatedly. 570, 570. Reason 570 is the most important code. 571, it is a tough code. We have to, and 571, whatever we have highlighted, only read that one. Question will be asked from that one only. No need to read the entire code book, but almost 40% we highlighted. 570 we highlighted, 80% we highlighted. Okay, so 40% we highlighted in 571. So we have to read it repeatedly. So first is the brief description. Second one is the affected material. Now third one is what are the critical factors for a particular type. For example, if you take stress corrosion cracking, what are the critical factors? We need a corrosion, we need a stress. Okay, so critical factors, some damage mechanism will have one critical factor, some damage mechanism will have multiple critical factors. That you have to remember. Temperature may be a critical factor. I just told you, sulfidation will come above 500 degrees Fahrenheit. Material may be a critical factor. Stress may be a critical factor. So you have to remember it. Now, next one, how the appearance and the morphology. How you can identify by seeing what type of crack it is. So we have some nicknames actually. Okay. For example, amine stress corrosion cracking, there is no nickname name. Caustic stress corrosion cracking, we have a name spider web. Chloride stress corrosion cracking is Craze crack. Like that erosion corrosion, pits, grooves, gullies. Then fatigue, clamshell, fingerprint, beach mark. Like we have some nicknames. The nicknames you have to remember. The next one is how to prevent a damage. Yes, please, please. Now, prevention, if we can avoid a critical factor, that is a prevention. See, for stress corrosion cracking, what is the critical factor? Stress is a critical factor. If you can do stress relief, then it is a prevention. Then next one, NDT. Which NDT it will detect? So now you should have a basic idea of the NDT. For example, I will ask some simple question. PT, what type of defect PT will detect? Not surface. Defects open to surface. If it is in surface closed, PT will not detect. Defects open to surface in non-porous material. The material should be a non-porous. MT. Surface and subsurface in ferromagnetic material. All material it will not detect. RT. So internal flaws, but preferably a voluminar flaws. So I think you know that crack may be missed by radiography. Crack, lack of vision, lack of penetration. This type of linear defect or planar defect can be missed by radiography. So radiography is not a preferred NDT for this type of defects, planar defects. It is best for voluminar defects, porosity, slag, undercut. That easily detected. Ultrasonic. Again, it is a opposite. Ultrasonic is best for the planar defects. UT can miss a voluminar defect. Okay, you know this four. Now, what is ACF? What is ACF? ACFM is alternate current field measurement. Okay, it is similar to MPI. The only difference between ACFM you should know, eddy current you should know, then what you called acoustic emission testing you should know, because some damage mechanisms. I just briefly explained that, not very deep. ACFM is alternate current field measurement. It is similar to MPI, but MPI we are measuring the magnetic flux leakage. Here we are actually measuring the current. Now, what is the advantage of ACFM is over MT? MT we can use only in ferromagnetic material. ACFM we can use in all conductive material. For example, stainless steel. We cannot do MT, but we can do ACFM. Another advantage is it is a non-contact technique. No need to touch the pot. Temperature up to 900 degrees Fahrenheit we can use. Where actually ACFM is, ACFM you never seen in the construction industry. They are not using the it is used in the in-service industry. Cracks in your holes, back gougery areas. So they are using ACFM. But the disadvantage of ACFM is it is a surface entity method because AC have a skin effect. AC current have a skin effect. Another disadvantage means we need a high skill operator to interpret the signal. That's all ACFM. Now, next one is eddy current. Again, similar to this, all called as electromagnetic NDT methods. What is the advantage of eddy current? What is the penetration of the MPI? How much it is? We say surface and subsurface. Subsurface up to what depth we can detect? 6 mm. Theoretically, it is 6 mm. Even though practically it will be little bit less than 6 mm. If you are using DC current, it can go up to 6 mm. Whereas eddy current, it can go up to 13 mm. Half an inch we can. Eddy current, again, we are using the current disturbance only. We are using AC only. Okay. Now, third one is what you are not familiar, acoustic emission testing. What is meant by acoustic emission testing? The basic principle is ultrasonic. What is the basic principle of ultrasonic? Acoustic impedance. What is meant by acoustic impedance? We will send a sound. When the material changes, velocity will change. Sound will be reflected back. Sound will be opposed. That is called, we will reflected and we will run the sound. That is ultrasonic. But acoustic emission principle is when any crack develop or any part deform, it will emit some sound. For example, if you tear a paper, a glass is broken, it will emit some sound. If you can pick the frequency properly, you can detect the length of the crack from where to where it starts. That is called acoustic emission testing. Now, the question is, how I know when the crack will start? The answer is, we have to keep a probe permanently in that location where you have a doubt and monitor continuously. It is not a repeated NDT technique. It is called a dynamic NDT. Only when the crack develops, when we can see. When the crack stops, there will be no. So generally, where they are using in piping and pressure vessels. Suppose a piping is in service. During service, the temperature gone below the transition temperature. What will happen when it is go below the transition temperature? Pipe will become brittle. But even it become brittle, it will not break. It will not fail during service because the operating pressure is low. You are making a shutdown and you are doing some repair and you are going for hydro test. That time it will fail. Reason is hydro test pressure is 1.5 times of the design pressure. So if you have a doubt, the pipe become brittle during service, they will keep the acoustic emission probes and start pressurizing. When any crack starts, they will immediately stop the hydro test. So pipe become brittle, we have to remove the brittleness. Brittles can get removed by heat treatment. So that is the acoustic emission testing. So, and these are the some of the advanced NDT methods. You should know this. Another one is you should know what is corrosion taps and what is corrosion probes. Anybody have idea? Corrosion coupons and corrosion probes. Corrosion coupon means to monitor the corrosion. Yesterday I told you how to calculate the corrosion rate. We will keep a same material inside a pipe in the flow. Periodically, we will remove and check how much it is corroding. So from that, the pipe corrosion can be estimated. That is called corrosion coupon. And the corrosion probe or ER probes, electric resistance probe, it is not the same material. They are using a sensors actually. Based on the resistance, okay, they will measure how much it is corroding. That is called ER probes. Now, please understand corrosivity, resistance opposite. A high resistivity material will have low corrosion. One. Corrosion rate, temperature is directly related. When the temperature increases, corrosion rate also increases. Okay. With this introduction, we will start the class. Okay. So please take your 571. First, I will go to the definitions because definition I already told in introduction. Right. Please go to the page number 2. Please take page number 2. Austenitic stainless steel. Highlight this one. 300 series, which commonly include the 3,4L, 3H, all these things. This was asked in the closed book question. The L and H suffixes refer to control ranges of low and high carbon content. What is L and H means? Low and high carbon. Then highlight the 2.1.6 duplex stainless steel, a family of stainless steel that contains the mixed austenitic ferritic structure, including alloys. See, duplex will have a 4-digit number, 2000 series, 2205, 2304 like this. The next page, ferritic stainless steel, 2.1.8, highlight that one. A family of stainless steel, 400 series, ferritic also 400. Then HSLA steel, high strength low alloy, highlight these two lines. A family of carbon steel when higher strength levels are achieved by the addition of moderate amounts of alloying elements such as titanium, vanadium, or niobium in less than 0.1%. Then highlight the low alloy steel, 2.1 line. A family of steel containing up to 9%, that is called low alloy steel, chromium or other alloying elements. And martensitic, a family of steel, 400 series. Again, martensitic is 400 series. Then nickel based, another important, it was asked in one of the closed book questions. A family of alloys contain nickel as a major element greater than 30%. That is the exam question. Nickel alloy means the nickel content should be more than 30%. That is called nickel alloys. So how you will identify the nickel alloys? It will have alloy a 3-digit number. Alloy 200, 400, 800, 600, all these things. In stainless steel, alloy of iron with at least 10.5% chromium plus other addition depending on the specific. So generally, it will have chromium and nickel. Then the acronyms highlight ACFM, alternating current field measurement. AET, acoustic emission testing. Then AUBT, it was asked in the closed book, but it is in Python actually. Automated ultrasonic backscatter testing. 578 is not occurred. Then page number 8, SEM. Page number 8, scanning electron microscope. SEM abbreviation is scanning electron microscope. Page number 8. Okay. So we will start now damage mechanism. I will go one by one. So we will see this arranged in alphabetical order, but we are not going to follow that order. So first we will start with the corrosion. So corrosion can be classified into two groups: external corrosion, internal corrosion. What is happening outside the pipe? What is happening inside the pipe? So the outside corrosion is atmospheric corrosion. The first one is the atmospheric corrosion. We will go in this order so that you can easily correlate. Now, what is atmospheric corrosion? Suppose I have a same pipe, same service, everything same. One is located in Trichy, another one is located in Chennai. Both will have a same internal corrosion, but the external corrosion will change. Which will corrode more, Trichy or Chennai? Why? Because that is a marine environment, seashore. So atmospheric corrosion is caused by marine environment or polluted industrial environment. So what is the definition of atmospheric corrosion? Is corrosion caused by the atmospheric condition. Atmospheric condition means moisture and salt condition in the atmosphere. Marine environments will have more corrosion. Polluted industrial environments also will have more corrosion. Dry rural environments will have very little corrosion. So for atmospheric corrosion, we need two conditions. One is the atmospheric condition. Another one is the coating. If the pipe is properly coated, there will be no atmospheric corrosion, even it is in marine condition. A properly coated pipe will not corrode. So there should be no coating or coating damage. Then only it will corrode. Okay. Now, marine environments and polluted industrial environments will corrode more. Dry rural environment will corrode less. Which material it will affect? It will affect carbon steel, low alloy steel, copper alloyed aluminum. Stainless steel it will not affect. Now, what will be the corrosion rate? So yesterday I told you corrosion rate inch per year. That is the one unit. There is another unit generally used mils per year, MPY. What is the relation between mils and inches? 1000 mil is equal to 1 inch. Okay. Marine environments will have 20 mils per year corrosion if it is not pipe is coated. Polluted industrial environment will have 5 to 10 mils per year. Wet rural 1 to 3 mils per year. Dry rural less than 1 mils per year. You have to remember these numbers. Again, I will repeat. Marine environments 20 mils per year. Polluted industrial 5 to 10 mils per year. Dry wet rural 1 to 3 mils per year, dry rural less than 1 mils per year. Now, I told you temperature and corrosion rate are related. Up to 250, if the piping inside temperature is increasing up to 250 degree Fahrenheit, corrosion rate also increases. But when the temperature exceeds 250, moisture will be dried immediately. So corrosion rate will not increase. That is the cutoff. What is the maximum temperature atmospheric corrosion can happen? Answer is 250 degree Fahrenheit. So we covered material and critical. How the appearance will be? There is no special appearance actually. It may be a localized corrosion or uniform corrosion. Then which NDT will detect? Again, there is no special NDT. Visually we can see, or we can, if it is not insulated, or we can do the UT thickness gauging. Small pipe we can go for radiography also to measure that. That's all atmospheric. Generally, atmospheric corrosion will have 1 or 2 questions. What are the key points I said? You have to remember. Okay. So please take the code book. So we will start from atmospheric corrosion, which is in page number 39. Please take page number 39. Nagaraj, voice கேக்குதுல்ல? Hello?
கேக்குது சார்.
Yes, sir. கரகரன்னு ஒரு சவுண்ட் வந்துச்சு, அதுக்காக கேட்டேன். டவுட் வந்து ஆப்பரேட்டர். Right. Highlight this one. Atmospheric corrosion. Corrosion that occur from moisture associated with atmospheric condition, marine environments and moisture polluted interference with the airborne contaminants are most severe. That is important. Close book question. Dry rural environments cause very little corrosion. This is a close book question. Marine environments and moisture polluted industrial environments. Then affected material, carbon steel, low alloy steel and copper alloyed aluminum. That is open book question. Mark it open book question. Again, I am repeatedly telling, just highlighted only, read it. Critical factor, physical location of the plant, industrial, marine, urban or rural, amount of moisture, humidity, rainfall, presence of salt, sulfur and dirt. Highlight these 3 lines. Then this is very important. Last exam, this was a question actually. Corrosion rates increases with the temperature up to about 250. Above 250, surfaces are usually too dry for corrosion to occur, except under insulation. That is important. Okay. Then highlight the H. Marine environments may be very corrosive, about 20 mils per year, as are the industrial environment that contain acid or sulfur compound 5 to 10 mil per year. That is close book question. Inland location exposed to moderate amount of precipitation of humidity. That is a wet rural 1 to 3 mils per year. That is also important. Then J. Dry rural environments usually have very low corrosion rate, less than 1 mil per year. So you have to remember 20, 5 to 10, 1 to 3 and less than 1. This value you have to remember. These are the close book questions. Then affected units, unpainted, uninsulated, carbon steel and low alloy steel piping operating below 250 degree where moisture can. So these are the conditions for atmospheric corrosion. There should not be painting, there should not be insulation, temperature should be below 250. The next page, appearance and morphology. Highlight the A. The attack will be general or localized depending upon the condition of the coating, if any, and whether or not the moisture is trapped. It can be general corrosion or local corrosion. Mark it as a open book. 3.8.5 A and C also highlight. Localized coating failures will promote localized corrosion. So if there is a coated, but there is a failure in some area, that will promote a localized corrosion. Highlight the C. Prevention. So how to prevent it? We cannot change the atmosphere. So what we have to do? Proper surface preparation and coating application. Okay. This is another important. Surface preparation and proper coating application are the critical for long-term protection in corrosive environment. That is very important. Close book question. Then these are not important. So we can see, highlight this one. UT can include techniques like straight beam, angle beam, shear wave UT, PA UT, directly measure remaining wall thickness of EMAT or GWT. So guided wave test we will see later. Eddy current technique may be used, include the screening such as pulse eddy current. Now, so everywhere this guided wave testing will come. So let us see what is guided wave testing. So this is called guided wave testing or a long range ultrasonic, all are same.
Problem, tomorrow's solution, delivered today. TWI's long-range ultrasonic technology. What's it do? Who needs long-range ultrasonic guided wave inspection technology? Well, the short answer is just about anyone involved with inspection and integrity of longitudinal components, particularly pipes and tubulars, onshore and off, chemical plants, oil and gas risers, jetty lines, refinery pipework, bridge tubulars, offshore topside pipework. In other words, if it's long and tubular, carries fluids or gases, and is safety and environment critical, then it's a job for long-range inspection using ultrasonic guided waves. The evolution of long-range ultrasonic testing is indeed a fascinating one. In the 90s, it looked something like this. The hardware has changed considerably in the last decade, and huge advances have been made in enhancing its performance. Principles of long-range ultrasonic testing remain the same in the laboratory, the factory, or out in the field. Nowadays, it's dubbed teletest focus, and its most recent incarnation looks like this. What are the advantages of using this technique? First, since it's a remote monitoring system, you can inspect lengthy pipes from distant locations, typically 30 meters. Second, you can inspect inaccessible regions like clamped, encased, or buried pipe. The process provides full volume coverage and is sensitive to metal loss down to 9% or more of the pipe wall section, whether it's caused by erosion, corrosion, or, as we see here, in-service damage. This technique has already provided the way forward in many EC collaborative projects. Examination of offshore subsea risers, steel catenary risers and flow lines. Also for the inspection of encased metal pipelines. Perhaps they're buried in concrete, water, or coated with insulation. And also for the condition monitoring of offshore structures and similar large engineering assets. So how does long-range ultrasonic technology work? It consists of an inflatable collar, just like this, and a low-frequency floor detector. Remember, its purpose is specifically to survey pipes and pipelines for corrosion, erosion, mechanical damage, and sometimes cracking through fatigue. It's an ultrasonic system, but it uses ultrasonic frequencies much lower than those used for conventional ultrasonics. The transducers, these parts just here, are pressed against the pipe and operate at several tens of kilohertz, as opposed to megahertz frequencies used in conventional ultrasonic testing. So a special floor detector is required. That's what this box does over here. The low-frequency sound can travel long distances along the pipe, several hundreds of meters under ideal conditions. So by transmitting the sound a long distance, we can examine large lengths of pipe in one go. Because it's a modular system, we can modify the transducer collar and test pipe upwards of 2 inches diameter using the same system for all sizes. Already, research and development on long-range ultrasonics has been responsible for quite a crop of successful results. But what is most notable is teletest. It's already up and running and is being used very successfully to market the technology by Plant Integrity Limited. So far, it's been used globally in more than 50 countries. Long-range ultrasonic technology, today's solution to tomorrow's problems. To learn more about TWI's long-range ultrasonics work, why not call the world leaders? LRU section at TWI.
Okay, so we have completed one damage mechanism. So how many questions we marked? You can see here. 1, 2, 3, 4, 5, 6, 7. So we marked 7 questions. Just to highlight and read, wherever question mark, read at least 2-3 times. Generally, most of the question will be asked from there only. Okay. Now the next damage mechanism outside corrosion is CUI, corrosion under insulation. This is also a outside corrosion. So corrosion under insulation, page number 111. This is one of the important damage mechanisms because this damage mechanism is covered in 3 code books. Here we have 570, we have a separate chapter and a separate table also there. CUI 574 also it is covered. Okay. So it is one of the damage. Now, what is meant by CUI? Same. See, what is atmospheric corrosion? If the coating failure is there and atmosphere moisture salt content, you corrode. Here, an insulated line, when the insulation become wet and the piping is not coated properly, it will cause corrosion. That is called corrosion under insulation. So to CUI happen, we need 3 things. First thing, the insulation should be wet. Second thing, pipe is not coated or coated failure. Third one, there is a susceptible temperature range. Only in particular temperature range it will happen. Piping operation temperature. What is the temperature I told atmospheric corrosion? Up to what temperature atmospheric corrosion will happen? 250. 250 degree Fahrenheit. But here we have 3 temperature range. For CUI, carbon steel and low alloy steel 10 to 350 degree Fahrenheit. Aesthetic stainless steel 140 to 350 degree Fahrenheit. Duplex stainless steel 280 to 350 degree Fahrenheit. You have to remember this temperature. These are closed book questions. Again, I will repeat. For CUI to happen, we need 3 conditions. A wet insulation, susceptible temperature based on the material. I told what is the temperature, and a coating failure or not coated pipe. If 3 conditions met, there is a CUI. Now, which material it will affect? It will affect carbon steel, low alloy steel, aesthetic stainless steel, and duplex stainless steel. Then how the appearance will be? Generally, carbon, all material, it will be a localized corrosion, but stainless steel, it can become a crack, very, very important. That is called chloride stress corrosion crack. So CUI, corrosion under insulation, can happen in stainless steel as a chloride stress corrosion crack. The reason is, for chloride stress corrosion cracking, we have a separate damage mechanism. So chloride stress corrosion cracking, we need 3 conditions. A wet chlorine, temperature more than 140 degree Fahrenheit. Here, insulation generally will have chlorine. When insulation is wet, it will become a wet chlorine. When it is contact the stainless steel and its susceptible temperature is 140 to 350. Temperature also more than 150, it will cause cracking. Many exams, this question is asked. CUI will appear in aesthetic stainless steel as, that is a question. Answer is chloride stress corrosion. Now, how to prevent CUI? We have 2-3 options actually. One of the option, we can use a insulation which will not become wet. We have a special type insulation called closed cell foam glass insulation, which will not absorb moisture. That is one. Second one, even the insulation become wet, it should not touch the pipe. So what you have to do, if a carbon steel low elastic, we have to go for aluminum spray paint before insulation. So what is the purpose of using aluminum spray paint? Aluminum will corrode preferentially. There is one corrosion called galvanic corrosion, dissimilar metal corrosion. So aluminum will corrode to protect the steel. Stainless steel, we will go for the aluminum foil. We will not use a spray paint. So low chloride insulation, we can use it. Third, sorry, insulation, so not, insulation which is not wet, that is called closed cell foam glass, we can use it. Second one, you can go for a aluminum spray paint. So avoid cracking, low chloride insulation, we can go for it. So low chloride insulation limits are specified in ASTM C871. There is a standard. It is a open book one. These are the options. Now, where CUI will come easily, for example, a straight pipe, a pipe with many branches, which is more affected by CUI. Many branches. And a leaking on the pipe, stream tracing leaking on the pipe located downwind of the cooling towers. This all will have a more CI problem. Finally, coming to NDT, here there are two types of NDT. How to check whether the insulation is wet or not? How you will check whether the insulation is wet or not? Which NDT? You can remove the insulation and check, that is different thing. Which NDT will detect insulation is wet or not? Yeah, there is one thing called a neutron backscatter, special NDT, and infrared thermography, temperature measurement. Now, how to measure the thickness, whether the corrosion? If you remove the insulation, we can use the UT. With the insulation, we can take radiograph. Or with the insulation, just to see the video, there is a guided wave test or long range UT also we can do. So these are the key points about the CUI, one of the important damage mechanism. So please take, highlight this one. Corrosion of piping, pressure vessel, and structural component resulting from water trapped under insulation or fireproofing. That is closed book question. Carbon steel, low alloy steel, 300 series SS, 400 series SS, and duplex stainless steel. That is also closed book question. Affected material. Critical factor, temperature, duration of wetting, design of insulation, insulation type, and environmental are critical factors. Then corrosion rate increase with increasing metal temper up to the point where the water evaporates quickly. That is open book question. So up to the point only it will happen. Now the 1, 2, 3 are important. In most situations, it's a practical matter. Refinery generally focus CUI management effort on carbon low aligned 400 series 10 to 350. 300 series chloride is concerned, focus the 140 to 350. Duplex stainless steel, that is 280 to 350. The temperature is important. Close the question. Now C, highlight the C. Poor design of insulation or insulation system that allow water to become trapped will increase the CUI. Suppose there is a break in the insulation, then there will be a work. Then insulating material that wick moisture, wicking means absorbing moisture and can hold water more prone to CUI. That is important. Close the question. Then highlight the G. Equipment that operates below the water dew point tend to condense water on the metal surface, thus providing the wet environment. And I, plants located areas with high annual rainfall or warmer marine location are more prone to CUI. The next page 112. This is open to question. Piping components and the locations that are particularly susceptible include deadlocks, hangers, walls, fitting, irregular insulation, all these things. Big list is there. Mark it as the entire paragraph open to question. Page number 112. Then piping equipment with the damaged and the leaking stream tracing is acceptable. Then appearance and morphology. Yes, please. This is important. Carbon steel and low alloy steel are subject to corrosion having a rough, uneven, somewhat pitted appearance, usually covered with a loose, flaky, non-protective scale. It was open to question, recently asked. So they will carbon low alloy steel have a rough, uneven, and C is important. 300 series stainless are subject to stress corrosion cracking if fluorides are present, while duplex stains are less acceptable. Prevention, next page. Since most construction material used in defining a successful CUI, mitigation is best achieved by applying appropriate coating to equipment prior to insulating. So you have to apply the appropriate coating. Highlight the two. Flame sprayed aluminum coatings have been used on carbon steel. Coating corrodes preferentially by galvanic corrosion, thereby protecting the base metal. That is open to question. C. Thin aluminum foil wrapped on stainless steel piping and equipment beneath insulation prevent the effective barrier. That is important. And this one, last exam, this was asked. That is the while closed self-formed glass material will hold less water and therefore might be less prone to causing CUI. Studies that an open cell structure provide a bath or water vapor, allowing the insulation to dry quicker. So closed self-formed glass, that is important. Open to question. But it's not highlighted, highlight. Because last exam it was a open book question. Then F, low chloride insulation should be used on 300 series to minimize the potential of pitting and chloride corrosion cracking. Some manufacturers supply insulation certificate to be low chloride. Thermal insulating material can be tested by ASTM C871 to evaluate the chloride content. That is open to question. Then insulation plugs removed should be promptly replaced. So for thickness measurement, when you are using the insulation plugs, so it should be properly replaced. And these are not important. Please go to the next page. What are the NDT? See, one, guided wave testing, RT, including profile, density, flaws, radiometric, all this, pulsed eddy current, neutron backscatter for identifying wet insulation, and infrared thermography are identifying wet insulation. So highlight this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 questions more. It is one of the very important damage mechanism for AP exam. Next one, galvanic, hydrochloric acid, galvanic corrosion. It can happen outside or as well as inside. So this even, okay. So we'll take galvanic corrosion. Hello, hello, hello. Hello. அவங்க லலிதா கால் பண்ணுங்க, வந்திருக்காங்க, அட்டன் பண்ணுவாங்க. இல்ல அவங்க லீவ்ல இருந்தாங்க, இன்னைக்கு தான் வந்தாங்க. ஓகே, இப்போ ஆஃபீஸ்ல இருக்காங்க. Okay. So please take galvanic. Right. What is meant by galvanic corrosion? See, you know, I think you may hear about cathodic protection. So cathodic protection is working based on the galvanic corrosion principle. So what is meant by galvanic corrosion? When two different conductive materials, again I will repeat, when two different conductive materials joined by an electrolyte and there is a electron flow between them, one will corrode, another one will be protected. That is the definition of galvanic. So to galvanic corrosion happen, we need 4 things. There are two different conductive materials. Electrolyte, both should be immersed in an electrolyte. and there should be electron. So which one is corrode is called as a anode. Which one is protected is called as a cathode. That's why it is called a cathode. Now, generally, where this is the problem between dissimilar welds. Suppose you are building a carbon steel with the stainless steel. When you make two carbon steel weld, both will corrode equally. When you make a carbon steel with the stainless steel, carbon steel will corrode more because it is corroding for stainless steel also. Same way, suppose you have a two carbon steel bolt, you put a carbon steel nut in one, stainless steel nut in one other. The stainless steel nut bolt will corrode. This is the galvanic corrosion. So it is generally problem with the bottom, underground pipe. What is the problem underground piping? Underground piping, we have a soil. Soil will have moisture. So soil will cause a electrolyte. Our pipe, metal. Suppose any other metal near that one, which is less corroding than our pipe, then our pipe will become an anode. It will start corroding that. So to make our pipe cathode, what we have to do? We have to connect to a highly corroding material. Which material corrode more than the steel? Zinc, aluminum, magnesium. If they are connected to any of this material, steel will be protected, they will corrode more. You can see this is the galvanic series in seawater. So the high cathode noble end is platinum. Platinum will not corrode. Then you can gold, graphite, titanium. If we take steel, this is our steel. Above steel, we have aluminum, zinc, and magnesium. So if you want to protect steel, then we have to connect either with aluminum, zinc, or magnesium. Aluminum is generally not used. You just remember we have seen aluminum painting. That is the galvanic corrosion principle to protect from the CUI. But when cathodic protection, we are using zinc to magnesium. The reason is whichever materials are away in the table, the protection will be more. For example, when you combine lead and tin or lead and brass will have more effect, more protection because the distance between two metals in the series. So this is called as a galvanic corrosion. So how to avoid a galvanic corrosion? Design. You remember, if you work practically in stainless steel pipe, they will not allow in direct contact with the carbon steel structures. They will keep some spaces, even some wooden planks, wooden things, because there is a problem of the galvanic corrosion. Different materials should not allow to be in the contact. So please take galvanic corrosion. Accelerated corrosion that can occur at the junction of dissimilar metal when they are joined together in a suitable electrolyte such as moist or aqueous environment and soil containing moisture. That is closed book question. That is the definition of galvanic corrosion. If you take materials, all metal with the exception of noble, all metal will have this problem. Page number 164. Page number 164. So here they will not ask the materials because all metal will have this problem except noble. Then this is important. For galvanic corrosion, three conditions must be met. There must be two different metal with a different electrochemical potential. That is open to question. The dissimilar must be electrically coupled together either by directly in contact with or each other by a wire or conductor. One of the metal is known as the anode, another one is known as the cathode. So which will corrode? Which will corrode? Anode will corrode, cathode will be protected. Both metal must be immersed in contact with same continuous electrolyte, that is fluid that can conduct the electric current. Moisture at a separate water base is usually required. Now highlight this one is a closed book. The more noble metal, the cathode is protected by sacrificial corrosion of the more active metal anode. The anode corrodes at a higher rate than it would if it were not connected to the cathode. Then this is important. We need a distance between the alloys. The farther the alloys are apart in the table, the higher the driving force for corrosion. So how many distance? Because it is asked in the open book, they will give some list, the table. So which will have more protection means you have to just count the number. What is the distance between these two metals? Then appearance, next page. Damage occur where two different metals are joined in welded, bolted, or rolled connection. That is important. The more active metal can suffer general loss in thickness or more aggressive local loss adjusted to the point of connection. The appearance in crevice, grooving, or pitting corrosion, depending on the driving force, conductivity, and other things. Open book question. In how to mitigate, design only. The best method for preventing mitigation through this good design. We should not allow contact dissimilar material. That is closed book question. Now, which one you have to coat it? Suppose you want go coating, we have to coat which one you want to protect. You know, there is only thing called galvanization, GI pipe. That is a zinc coating. Why we are coating zinc? Zinc will corrode to protect the steel. So highlight the if coating can be used to mitigate the galvanic, care must be exercised. Then highlight this line. The exposed areas of both the anode and the cathode should be coated. If only one can be coated, the more noble method should be coated. That is important. So more noble, which one you want to protect, you have to coat it. Then NDT, nothing. This table is a open book question. Based on the table, there may be exam questions. Mark it as a open book question. So how many questions we mark? 1, 2, 3, 4, 5, 6, 7, 8 questions. Next one, we will go soil corrosion. Outside corrosion. We are looking now outside corrosion, soil corrosion. So please take page number 293. Now, what is soil corrosion? So very simple. If a pipe is inside a soil, underground pipe, if the soil is a corrosive soil, it will have a corrosion that is called soil corrosion. Now, which soil will have soil corrosion? For example, a river soil or a sea soil. Which one will have sea soil? Then how I know the soil is corrosive or not? It is very difficult to measure soil corrosivity directly. So generally what they are measuring is a soil resistivity. So resistivity, what is the unit of resistivity? நீங்க advanced entity பண்றீங்களா? சரி, what is the unit of resistivity? Not only ohm, it is ohm centimeter. Resistance is ohms. There is a difference between resistance and resistivity. Okay, so we will measure the resistivity of the soil. Higher the resistivity, lower the corrosivity. How we will measure the resistivity of the soil? There are three methods. The methods are there. It is covered in 574. I will briefly tell, then we will see in 574. Venner 4-pin method, soil bar, soil box. So Venner 4-pin method, soil bar, soil box. How the Venner 4-pin method works? So this is the Venner 4-pin method.
To measure the soil resistivity of a given area, position 4 ground stakes of the same length into the ground to be measured. The stakes should be placed in a straight line. The distance calculated as A between each stake should be the same. The earth stake should not be positioned in the soil deeper than a third of A. Turn central rotary switch to position RE4 pole.
The instrument is to be wired according to the pictures and notices given on the display. Connect the test leads in the order they are positioned in the ground, starting with the nearest ground state connecting to the E socket. Press Start. Read out the measured RE.
So this is the resistance actually. There is a formula to convert into resistivity 191.5 into D into R. R is this value. D is the distance between these two pins. And 191.5 is the constant.
From the indicated resistance value RE, the soil resistivity calculates according to the equation found in the operating instructions.
Okay. So this is the Werner-4 method. Now, so how to avoid a soil corrosion? So which material it will affect? It will affect only a carbon steel, cast iron, only even low alloy steel it will not affect. Carbon steel, cast iron, and ductile iron will affect. Then how the appearance will be? See, generally from protect from the soil corrosion only, they will go for a coating. You can see wrapping coating. And they will go for a cathodic protection also. Wrapping coating with the cathodic protection is the effective method to protect from the soil corrosion. These are other methods also there. We can remove the soil and use a special backfill. We can use it. But the most effective method is this one. Now, how to monitor the soil corrosion? How I know underground piping is corroded? Which NDT method is used to check the underground pipe is corroding or not corroding? Without excavating. Piping is going underground. Suppose you want to check from the above ground, the pipe is corroding or not corroding. How to check it? Any idea? LRUT we can do, okay, but that have some limitations. It can travel only up to particular distance. There is one thing called close interval potential survey. See, there may be close interval potential surveys. I will show you the video in YouTube. See, when a underground piping will corrode, when there is a damage in the coating. The purpose of coating is to protect from the corrosion. So this is actual close interval potential service. No, they will go along the path. So this is the close interval. What is doing is a close interval potential. This is the one. And the buried root. See how it works actually. Not a very big deal. They will send a voltage through the electrode. See, what they are using, the stick type. It is nothing but electrode. They will send a voltage through the soil, and when reaches the coating is a non-conductive material. The wrapping coating is a non-conductive material. So there will be some loss. We will receive some voltage actually. Now they will make it a null. Null means they will make it to 0. Then they will go like this. Whenever there is a wrapping is damaged, the pipe is exposed. Pipe is exposed means pipe is a metal. When pipe exposed, there will be a sudden some reading will show. Some reading showing means pipe is corroding there. Then we have to excavate to check the actual condition of the pipe. So this method is called as a close interval potential survey. Potential means voltage. Close interval, we have to check the potential survey on the route. It is covered in again 570, 570. 570, we have a separate chapter, underground piping. 574 also it is covered. So please take soil corrosion. Corrosion of metal exposure to soils is referred as a soil corrosion. Then this is open to question. Carbon steel, cast iron, and ductile iron. Only this metal will be affected by soil corrosion. Then the severity of soil corrosion determined by many factors, including operating temperature, moisture and oxygen availability, soil resistivity, soil type, all these things. Then this is important. Close look. Soil resistivity is relatively related to the soil moisture content and dissolved electrolyte in the soil water. That is important. Soil resistivity testing is frequently estimated the soil porosity. So we are using only soil resistivity. Then this is open book. Soil having high moisture content, high dissolved salts concentration, and high acidity are usually most porous. That is open book question. Then highlight the G. Other factors that affect the soil corrosion include galvanic corrosion, dissimilar soils, stray current, differential aeration corrosion, and MIC. Just to highlight it, not important. Affected units, underground piping and equipment, as well as the buried tanks and the bottom of above ground storage tanks. Then appearance. This is open to question. Soil corrosion appears external thinning with a roughened surface and a localized deeper attack or pitting. That line is important. Roughened surface and localized deeper attack or pitting. Then poor condition of protective coating is a telltale sign of potential corrosion damage. That is also open to question. If the coating is damaged, that means there is a soil corrosion. Then prevention, this is another important. The most effective protection of combination of the corrosion resistant coating and cathodic protection. That is the best way to protect from the soil corrosion. Then highlight this one. Infection, a close interval potential survey on cathodic protected line may be used to verify the buried piping. Okay. Then which code talks about this last line? Refer NACE SP 169 and AP 651 section 11 of the for guidance applicable to inspecting and maintaining the corporate production. Then holiday survey. Direct current can be used to locate coating defects on the coated pipe. This can be performed on a newly coated pipe before being buried on the pipe has been excavated. So another one is called holiday survey, but the holiday surveys we cannot use from the ground. So how the holiday survey is conducted? So this is a holiday survey.
The spring electrode. A holiday detector can be used with a brush or spring electrodes. Testing with spring electrodes. It has an advantage of fast testing.
So this is the wrapping coating. If any defects, this is before burying actually, or when the service life is completed. For example, you are giving guarantee for 20 years for the coating. After 20 years, they want to check whether we can continue or repair. You have to bury that because it should be in contact with the coating. It cannot be tested from the ground. We have to bury it. We have to excavate it.
As it tests the whole circumference at a time. For this, select the spring electrode of proper size, say as that of 5 diameter. Clip the spring over the pipe and push the spring along the length of pipe using the pushing rod. When spring detects the point where the insulation is damaged, the same point.
This is called holiday. Holiday means a break in the coating. Wrapping coating is called as a holiday. There is a break, that's why it is arc is coming.
With the help of a brush, mark a point on a pipe that has a damaged insulation over it and re-insulate the same. Testing with brush electrodes. brush is made by embedding phosphotones coil in aluminum base. To the aluminum base, the threaded socket is welded. At one end of the pushing rod, there is threaded brass plug, and at the other end, the threaded socket. The two connections are joined by electrical wire running through the rod. To start the testing, the wheel is attached to aluminum socket of brush. The other end of pushing rod is attached to PHD wire. The banana plug is inserted to make connection to PHD terminal on the instrument's back panel. Now, move the brush over the surface of even insulated pipe. As you can see, holiday detector has detected a spot where the insulation is damaged. It creates an arc at the respective spot and runs the alarm as an indication. Note, there is no phone drop.
Okay, so this is the holiday test. So highlight this one. There is a pipe coating holiday survey can be used to locate the coating defects. Then highlight this one. Guide wave testing can provide screening tool for metal loss on buried piping, but signals call can limit the distance from the gauge collar. So that's why it is not a very reliable method. It can go travel only up to above ground piping. There is no problem. Above ground insulated piping. So we will use this long range ultrasonic. Wherever you have a problem, you can remove the insulation, and it's underground piping. It will travel only a limited distance. Right, so how many questions we marked here? 1, 2, 3, 4, 5, 6, 7, 8 questions. So we have completed the outside corrosion damage mechanisms. Now, the next we will go, others all are inside corrosion only. So we will go from the starting, we will complete the stress corrosion cracking, because of this one. So please take the amine stress corrosion cracking 3.3. Or we can do continuously also, no problem. What is the first damage mechanism? Amine only first. Okay, no. First, what is mean by amine? Page number 18. We will go continuously, no problem. Because we have only two types of damage mechanism covered for us in 571 exam. One is the cracks and another one is the corrosion. Okay. So what is the amine? First, what is mean by stress corrosion cracks? We have three stress corrosion cracks. So when you read it, compare and read, it will be very easy for your exam. We have amine stress corrosion cracking, caustic stress corrosion cracking, chloride stress corrosion. Only three stress corrosion cracks. First, what is meant by stress corrosion cracks? Stress corrosion cracks and environmental cracks are same. Why they are called as environmental cracks? The corrosion environment is produced by the chemical. Stress is in the pipe when it is not PW state. So any corrosion happening near a non-PW weld, stress and corrosion combined will cause a stress corrosion. If it is due to amine, that is called amine stress corrosion crack. Due to caustic stress corrosion crack. Chloride stress corrosion crack. Okay. Now, then where it will happen? Near a non-PWC weld only. The next one, what is the common things between these three stress corrosion crack? First common thing is they all surface cracks. They will come only on the surface. Then, and near the weld, it will come parallel to the weld. Generally, they will be come in the heat affected zone area, parallel to the weld. But sometimes it can come on the weld. Weld, it can be transverse or parallel. Both ways it can come. So I told already surface. Surface, which entity for surface cracks? Surface, what are the surface entity methods? PT, MT. PT is not preferred. Reason is, this cracks will be filled with the corrosion products. For example, amine crack will have amine filled. Caustic will be filled in the crack. So penetrant will not enter. So PT is not preferred. Preferred is a wet fluorescent MT. MT wet fluorescent because high sensitivity. Eddy current, ACFM. These are the preferred entity method for stress corrosion crack. ACFM, eddy current, wet fluorescent MT. Then how to prepare the surface? You have to go for a grid blasting, or you have to use a high pressure water, you have to use it, or you can go for a polishing. RT again is not a preferred method. Yeah, I told you RT can miss a crack. Suppose if it is happening inside a piping, from outside we cannot do wet floors or empty. Then the preferred area is wherever you have now PAUT. PAUT is a phased array ultrasonic testing and shear wave ultrasonic. Now our normal angle beam ultrasonic testing. These are the NDT. Now preventive action is stress correction crack means you have to remove the stress. How you will remove the stress? PWST is the preventive action. If you take stress correction cracking 1175 degree Fahrenheit, you have to pay PWST. Caustic 1150 degree Fahrenheit. You remember B31.3 PWST is 1100 to 1200 actually. It is a range they have given actually. Here they have given some exact. So these are the common things. Let us start with the first one. First, what is amine by amine? Amine is a ammonia byproduct. So ammonia, what is the NH3? One hydrogen is removed and nitrogen is added, then it becomes the amine. Where they are used amine? Amine is used in the LNG plant to absorb H2S and CO2 from the gas. We have to remove the hydrogen sulfide, they are using the amine. Now, if it is completely saturated, the saturated amine is called as a rich amine because it cannot absorb more H2S. Like our same sugar, if you are putting in a coffee, if you have excess sugar, it will not dissolve because it is saturated. Rich amine, the cracking is not a problem. It is only a problem with the lean amine service. Lean amine means still it can absorb. Then only it will have a problem. Okay. Generally, which material it will affect? It will affect carbon steel and lower lust. It is not a problem with the stainless steel. And the cracks, I already told you how it will appear. This. So please take amine stress corrosion cracking is the cracking of steels under the combined action of tensile strength and aqueous alkaline solution used to remove absorb H2S and or CO2 and their mixture from various gas and liquid hydrocarbon steam. That line is important. Amine cracking is a form of alkaline stress corrosion cracking. That is important. Close book question. So, what is meant by alkaline? What is the pH of water? 7. Above 7, we call it as alkaline. 7 to 8 to 14. Below 7, 1 to 7, we call it as a acidic. ASCC means alkaline stress corrosion cracking. See, amine is alkaline, caustic is alkaline, chloride is acidic. It is most often found on adjacent to non-PWST coastal heated carbon steel wells and highly cold worked parts. That is also important. Affected materials, carbon steel and low alloy steel. That is close book question. Critical factors. The critical factors are the level of tensile stress, type of amine and temperature. That is open book question. Cracking is most often associated with high residual stress from welding or cold working that have not been removed by an effective stress relief treatment. Highlight that also. Then D, increasing temperature, increase the likelihood and severity of cracking. I told you, temperature cracking is corrosion is directly related. Then highlight this one. Amine cracking is most often associated with lean amine services, where a solution of amine and water is used. The pure alkanol amine does not cause cracking. In rich amine services in H2S removal systems, the H2S help to form iron sulfide film on the steel to help the impede amine. So, in saturated rich amine, there will be iron sulfide which will protect from the cracking. That is open book question. Then cracking can occur in non-PWC piping equipment as a result of exposed to steam out and short-term amine carryover. That is also important. The next page, appearance. Amine SCC cracks initiate on the surface of piping, primarily at wells. Cracks can appear in the adjacent and are weld metal, but most often found in the highest residual stress zone. That is close book question. Then B is important. Cracking typically develop parallel to the weld, and there may be multiple parallel cracks. In weld metal, the cracks are either longitudinal or transverse. That is also important. Open book question. And set on nozzle, the cracks are radial. They fan out of the bore. So set on nozzle means inside you are putting that will be radial cracks. across the crack. Then prevention, this is important. Open the question. Carbon steel wells and piping should be stress relieved according to APA 945, NACE SP 472. The recommended stress relieved temperature is 1175 plus or minus 25 degree Fahrenheit. Then we can use, suppose if you want to avoid this, you can use a stainless steel cladding. Use glass solid or stainless steel and other portion resident layer of the carbon steel. Thorough water wash non and equipment prior to welding, heat treatment and treatment. You have to water wash it to avoid cracking. Then inspection, wet fluorescent empty, ACFM and eddy current testing can be effective techniques detect surface. That is important. Open the question. Then proper surface preparation by grit blasting, high pressure water blasting, flopper wheel abrasive grinding. Other method is required to remove the scale and the contaminants. Then highlight the B. The angle beam, shear wave UT or phased array ultrasonic can be effective to detect and size cracks and would be methods typically for piping. Then PT may not used but may be used but should not be the only means of detection. PT may not be effective in finding tight cracks because the cracks are oxide filled. That is close book question. RT may not be effective in detecting fine tight cracks. And again, acoustic emission can be used for locating and cracks and monitoring crack growth. If you want to monitor the crack growth, you have to go for acoustic emission. That's all. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 questions. One of the important damage. Okay, we'll have some 10 minutes break. So we completed 5 damage mechanism. So after break, we will continue. Okay. So next one is, we'll go continuously. Boiler water condensate corrosion. Page number 42. Okay. So a small simple damage mechanism actually. So what is boiler water and steam condensate? See how the boiler is working. We are using a boiler feed water and the water travel through the water valve panel and there will be a burner. So because of the heat, the water will convert into steam and the steam will reach the turbine to rotate the turbine, which will couple with the generator. So power generation will be there. Then what you will do with the steam? There are two problems. If you leave the steam like that, it will pollute the area. It will raise the temperature of the area. Second one is, we can reuse the steam because the steam is generated from not potable water. It is from the boiler feed water, especially treated water. So what they will do, they will use a condenser to condense the steam back to water. So there will be a vacuum pulling. So they will condense the water in the condenser, condense the steam into water. In that process, if there is oxygen is there in the steam, it can cause a pitting corrosion. And the carbon dioxide is in the steam, it can convert into carbonic acid corrosion. These two are important. So when you are using boiler water steam condensate, what is the problem? Because in the steam and it is converting into water, oxygen will create a pitting corrosion and the carbon dioxide will create a carbonic acid corrosion. That is the basic. Which material it will affect? It will affect carbon steel and the low acid. How to avoid this? We have to remove the oxygen and the carbon dioxide from the steam. So they will add some chemicals like hydrazine. There are some chemicals they will add. Then which NDT we are using here? Here the NDT is, you have to monitor the condensate water for sample, and we have to take the water sample and analyze whether we have oxygen or carbon dioxide content. That's this damage mechanism. Very simple damage mechanism. Please take General corrosion and petting in the boiler system and the condensate return system, it is primarily the result of dissolved oxygen and or carbon dioxide, which could lead to oxygen pitting corrosion and carbonic acid corrosion respectively. That line is important. Affected materials, carbon steel and low acid. That is closed book question. Only carbon steel and low acid it will affect. Now, how to protect from the corrosion? They will maintain a magnetite layer. This is open book question. Corrosion protection in the boiler is accomplished by laying down and continuously maintaining layer of protective magnetite Fe3O4. That is open book question. The most critical temperature for FAC is 300 degree Fahrenheit and it decreases with the increasing pH. Okay, so FAC means flow accelerated corrosion. You can see here FAC definition here. FAC means flow accelerated corrosion. So the critical temperature 300 and decreases with the increasing pH. And highlight the E. Oxygen pitting can occur if the deaeration and oxygen scavenging treatment are not working properly. Scavenging, if you are not removing oxygen, there will be a pitting problem. Then appearance, corrosion from oxygen is normally a pitting type damage. It can occur anywhere in the system. There is a leakage of air or even only small quantities break through the oxygen scavenging. Oxygen is particularly aggressive in equipment such as closed heaters and economizers. Then carbon dioxide corrosion, that is carbonic acid, can also cause grooving in the pipe wall. That also important. So oxygen corrosion will be pitting. Carbonic acid corrosion will be grooving. Grooving, like making a line. Grooving. The next page, prevention. This is important. Oxygen removal from boiler feed water typically include mechanical deaeration, followed by scavenging with catalyzed sodium sulfate or hydrazine, depending on the system pressure level. That is open to question. Proper deaerator operation and accurately controlled scavenger chemical addition are important. Then D, water treatment, sampling and analysis are the common methods used to ensure integrity and prevent boiler water and condensate corrosion. Inspection, monitoring the appropriate parameters can indicate whether the treatment program is performing satisfactorily. That is open to question. Parameters that can be monitored through analysis: pH, alkalinity, hardness, conductivity, chloride. This we have to do for the water analysis. Then vacuum testing can be used to check air ingress in the condenser. We can go for a vacuum box test. This all open to question. That's all. So 1, 2, 3, 4, 5, 6. Yeah? Vacuum means we will create a vacuum. There is something called a vacuum box, or you can in the chamber also we can do the vacuum. There is a vacuum pump. We will remove the air completely. So outside the atmospheric pressure is 15 psi. So inside there is a zero pressure. There is no air. So what will happen? Any hole there will be leakage. If you apply a soap solution, it will the bubbles will come.
Only they will do for the
Tanks. Okay, this also condenser also they can do for the vacuum test. Okay, so next damage mechanism is caustic. So please go to the caustic. We have two damage mechanism actually. Now page number 69. So it is I am going continuously on. So first, what is caustic? You know soda. What is soda? Washing what you are washing powder we are using. That is the caustic soda. It is alkaline chemical. Basically, it is a sodium hydroxide or potassium hydroxide. That is important. NaOH or KOH. Caustic is nothing but sodium hydroxide or potassium hydroxide. There are two damage mechanisms. Caustic corrosion. Next one is stress corrosion. Both are related. Almost 75% of the damage mechanism is same. Only the end there will be change. Okay. Now, first let us discuss caustic corrosion. Then we will go to the stress corrosion part. Now, where the caustic corrosion will occur, it is a boiler related damage. Just we have seen boiler water condensate. Again, it is a boiler related damage mechanism. Boiler, I told you, the water wall panel, water is moving. It is converted into steam by heating through burner. Water, they will generally mix caustic. The purpose of adding caustic is to improve the steam efficiency. You want the pure steam, highly efficient steam. So they will add caustic. See, generally caustic is industry used in that is for two purposes. One is called catalyst. Catalyst means like that. We will add to water. Another one is for neutralization. If you want to neutralize the acidic, caustic, they will add it. So acid can be neutralized by the caustic. Here we are adding as a catalyst. Now, if it is properly mixed with the water, there will be no corrosion. When you are adding caustic, if it is properly mixed with water, there will be no corrosion. It will be smooth. But sometimes if it is not properly mixed with the water, due to your design, then what will happen? Caustic will move separately in the water wall tube. When it moves separately, because they have a temperature, there will be a corrosion. So for caustic corrosion, we need two things: a separate caustic without mixing water, and the second one is temperature more than 170 degrees Fahrenheit. There will be a corrosion. Because it is moving inside the water tube, the corrosion also will be like a lion. Many exams this question is asked. Caustic corrosion will appear as answer is caustic gouging. Gouging means making a grooving. Grooving or gouging. See, it looks like this. It will like tube will cut, or if we take the tube, cut the tube, it will be continue corrosion. That is called caustic corrosion or gouging. Now, which material it will affect? Carbon steel, low alloy steel, it will affect. Stainless steel. So why stainless steel is not corroding? Why stainless steel is not corroding? Due to the chromium oxide layer. The chromium oxide layer protects steel from reacting with the atmosphere. If the chromium oxide layer is damaged, or we call it as a passivity is damaged, then stainless steel also can have a caustic corrosion problem. Please remember, and again exam point of view, caustic opposite material is nickel. Wherever caustic you are using, nickel is the preferred material. Nickel will not have a caustic corrosion as well as caustic stress corrosion cracking. Next is also nickel is a preferred material. A nickel alloys, alloy 400, particularly alloy 400, and nickel alloys will have high resistance to caustic corrosion. Appearance, I already told you, it is a grooving. Then how to prevent it? Design. We have to change the design. We should not allow a caustic freely move inside a water wall. So we should ensure that it is properly mixed. Suppose you cannot change the design, then what you have to do? You have to go for a nickel alloy. You have to change the material. NDT, nothing special because it is a corrosion. We can do UT or R. That's all caustic corrosion. So again, it is one of the important. Now I will tell caustic stress corrosion cracking also. Everything is same. Only difference is the grooving, if it is happening near a non-PWC weld, because it is creating a notch and there is a stress, it will start cracking. That is called caustic stress corrosion cracking. The only difference between caustic corrosion and caustic stress corrosion cracking, caustic corrosion generally we have a carbon steel, low alloy steel problem. Stainless steel very rarely happen unless the passivity. But the stress corrosion cracking can happen in carbon steel, low alloy steel, and stainless steel. Second one, for caustic stress corrosion cracking, even a minimum caustic is sufficient because we have already a stress there to help 50 to 100 ppm. What is ppm? Parts per million is sufficient. Then appearance, here I told how it will appear as a grooving. That's why it is called caustic gouging, another name. But there it will like a other stress corrosion cracks parallel to the weld. Cracks will be parallel to the weld, or sometimes called spider web. It will like a spider web. Then NDT here I told it is nothing important, RT or UT only, but there ACFM, wet fluorescent test, magnetic ECT, same like RT is not preferred because it's a tight cracks. PT should not be used as the only method because the cracks are oxide caustic. Caustic is a white salt. Caustic will be the white salt filled. So inside piping, if you want to check from outside, we have to use for shear wave UT or PA. These are the two damage mechanisms, very, very important for your exam. So please take caustic corrosion. Generally, will not do PWC because there is a. Then what you have to do? You have to avoid caustic stress corrosion cracking. PWC we can do. Suppose somebody is asking, stainless steel PWC is possible or not? Answer is possible. No, even PWC is not possible. Why we are not doing PWC in stainless steel? Why we are not doing post-weld heat treatment of stainless steel?
And there is no effect.
It will relieve stress. So what is the purpose of PWST? Stress relief. If you do PWST of stainless steel, stress will be relieved. But a new problem will start. That is called sensitization. So what is meant by sensitization? How we will do PWC? We will heat slowly, hold it, cool it slowly. What is the normal temperature we are doing? 600 degrees centigrade. When the stainless steel is more than 400 degrees centigrade for a longer period, chromium and carbon combine together as a chromium carbide and they accumulate in the grain boundaries. So what happens? So what is the problem? Because the chromium is removed from the stainless steel, the corrosion resistance will go. It will start corroding. That is called sensitization. So stainless steel purpose is it should not corrode. When start it is corroding, then there is not stainless steel. Another problem is, particularly there is one more cracking is the problem in sulfur service actually. Polythionic stress corrosion cracking. There is one stress corrosion cracking called polythionic stress corrosion. Polythionic means sulfur acid actually. That stress corrosion cracking will happen only in sensitized stainless. So that's why generally PWC is not carried out on the stainless steel. Suppose if you want to do PWC in stainless steel, what is the other option I have? Simple. So I told you, if it is above 400 longer period, that is a keyword. So you should not allow for a longer period. Heat it fast, cool it fast. You can relieve stress, but there may be another one more problem. Distortion will come. Okay. So we have to make corrective action. So it is not distorting because of the fast heating. So if you want to PWST, practically yes, we can do. Only thing is we have to heating rate should be fast, which is usually slow heating. But a faster heating rate sometimes can result in a distortion if it is not properly supported. So you have to make a support, adequate support to avoid this. Okay, right. Localized corrosion due to the concentration of caustic alkaline solutions such as sodium hydroxide and potassium hydroxide and corrosive salts for those solutions that usually occur in evaporative or high transfer conditions, commonly called caustic gouging. So caustic corrosion, caustic gouging, both are same. Affected, this is important, primarily carbon steel, low alloy steel and 400 series SS. Carbon steel is the material most commonly in situation where caustic corrosion is a concern. 300 steel is generally resistant to caustic corrosion until passivity is damaged. That line is important. So the chromium oxide damage, then it can occur in the temperature of 160 to 210. Then critical factor, caustic, sodium hydroxide or potassium hydroxide must be present. That is closed book question. Then highlight the two. Caustic sometimes added to process streams for acid neutralization or as reacted to sulfur. So generally we are using the neutralization or reacted. We are adding caustic. Then this is another the temperature you have to remember. In high solution strength caustic, temperature above 170 degree with the temperature limit depending on the caustic will cause general corrosion. So 170 it is an important question. Affected equipment, localized caustic corrosion, caustic gouging is most often associated with boilers and steam generating equipment, including heat exchangers. Appearance, next page. Caustic gouging is typically characterized by localized metal loss. They may appear as a grooves in a boiler tube. That is important. Close the question. Groove in a boiler tube. But suppose if you cut the tube, the groove may not be visible because it is filled with a corrosion product. You have to use a knife or a sharp tool, then only you can find the groove. You can see next one. Deposits may fill corroded depression and mask damage below. Probing suspect area with the sharp instrument may be required. Then prevention in steam generating equipment, caustic corrosion is best prevented through proper design. Last exam it was asked. Design is the key criteria. So we should not allow separate caustic. Damage can be minimized by reducing amount of free caustic, by ensuring adequate water flooding and water flow, by ensuring proper burnage management to minimize the hot spot. Then C, carbon steel have serious corrosion problem in high strength. Alloy 400 and some other nickel-based alloy exhibit much lower corrosion rate. That is important. Alloy 400 nickel-based alloys are highly resistant. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 questions. We go to the next one, caustic stress corrosion cracking. Already explained. So please take page number 72. Caustic SCC characterized by surface initiated cracks that occur in piping and equipment exposed to caustic at elevated temperature, primarily adjacent to non-PWST weld. That is a key word. Primarily adjacent to non-PWST weld. And it is a form of alkaline stress corrosion cracking. That is ASCC. Then again, affected metal carbon steel low alloys at 300, nickel based alloys are more resistant. That is closed book question. Then critical factor, highlight the second line, caustic strength, metal temperature and stress level. So caustic strength, metal temperature and stress level. Then B, increasing caustic concentration, increasing temperature, increase the likelihood and rate of cracking. That line is important. C, cracking can occur low caustic level if concentrated mechanism is present. Caustic concentration 50 to 100 ppm are sufficient to cause cracking. So 50 to 100 ppm. That is regularly asked close the question. This 50 to 100 ppm. Then PWST is effective. So the corrective action for stress corrosion cracking is PWST 1150. Next page, appearance. This is open to question. Caustic SCC typically propagates parallel to the weld in adjacent base metal. So weld it will parallel to the weld. Then the pattern of cracking observed sometimes described as the spider web. That line is important. So spider web of small cracks often initiate or interconnect in the weld-related flaw. That is closed book question. Prevention, another very important closed book question. Cracking can be effectively prevented by means of stress relieving at 1150 degree Fahrenheit. Then 300 series offer little advantage to correcting. Nickel base alloys are more resistant to cracking and may be recovered at high temperature caustic. So we have to go for high temperature and nickel base alloys. Then another one is, if a vessel is in caustic service, you should not use a steam for cleaning. First, you have to wash with water. Then only you have to use a low pressure steam. Highlight this one. Steam out of non-PW carbon steel piping and equipment should be avoided. Where necessary, equipment should be water washed before steaming out, and only low pressure steam should be used for the short periods. Then NDT. Now, last exam, they asked in the open book, they give option A, wet fluorescent empty, option B, ACFM, option C, ECT, like that. So the first priority is wet fluorescent empty. Even though all are the NDT methods, you have to, this is the first priority. Because last exam, it was this one. So first, the question was, which of the following NDT methods are preferred to detect caustic stress corrosion cracking? They have given option A, FW, FMT, P, ACM. The first one is wet fluorescent empty. ACFM and ELB effective techniques to detect the surface breaking, proper surface preparation ensure the cracking. Angle beam, it is all repeat. PT may not be effective finding tight cracks because cracks are oxide filled. That is open book question. RT may not be effective in detecting fine tight cracks. AET can be used for locating cracks and monitoring cracks. Next page, you can see there is a chart. Sometimes question may be asked from this chart. So what this chart? See, the x-axis, they have given the sodium hydroxide concentration. If you see y-axis is the temperature, it is a very simple chart actually. We have three areas. Area A, this is the area B, area C. What is area A? Carbon steel without PWST. Area B, carbon steel, stress relief, weld and bend. Area C, application of nickel alloys. So how the exam question if they ask, for caustic concentration 20%, temperature 180, which of the following material should be used? So 20%, 180, which material we should use? Just to match it, 20 with 180. It is coming here, area B, carbon steel with PWST. Suppose the temperature is say 240. We have to go for nickel based alloys. Suppose the temperature is 120, then carbon steel without PW. Okay, so which area it is coming, the temperature and the caustic concentration, we have to check. So we have completed this. Then we'll go to the next one, chloride stress coefficient cracking, another very, very important damage mechanism. Yes, please.
Whatever we are working in the close book.
No, both we are marking. Open book also we are marking.
We are working in the open book. For open book means it will come open book only, or it may come in close book.
Generally, what we marked in closed book may come in open book also. What we mark in open book, it will come always open book, very rarely in closed book. Now, it is 1% possibility only. So don't worry. So it will come only open book only. These questions are marked on the based on the previous feedbacks only. See, whatever this light blue is a recent exam actually. Last exam. So I am using, you can see different color marking will be there. So different exam feedback, you will have used different colors for this identification. Okay, now
If we go to the chart, there is no margin, there is no separation for the.
this is the area A. This is a line, area A line.
Okay,
In this between these two line is area B.
okay.
If it is more than this line, area.
Carbon steel is to leave where it is and then,
Yes,
right, for the entire area B.
yeah.
Okay.
If it is in the area A, no stress relief required,
Okay.
no PWC required.
So that graph is that curve is separation.
Yeah, that is a curve, is the separation curve. Okay.
But if we go to top, then
There is a nickel base alloys. Yeah.
the
Yeah, application C. This is the area C, above this curve, up area C. So if the temperature is this much more than this, you have to use a nickel base alloys. Chloride stress coefficient factor. See, 2-3 temperatures are very favorite in the AP exams. One of the temperature is sulfidation. I told you what is the sulfidation temperature? 500 degree Fahrenheit. Above 500 only it will come. Another favorite is the chloride stress coefficient cracking, 140 degree Fahrenheit. Above 140 only chloride, because chloride stress coefficient cracking very, very important, because it 2-3 damage mechanism they are correct. CUI, there is a mention of chloride stress coefficient cracking. When the stainless steel insulated line it become wet, it can crack. That is chloride stress coefficient cracking. The temperature is very important. Above 140 degree Fahrenheit it only come. Another speciality about the chloride stress coefficient cracking is it will come only in stainless steel. It will not come in carbon steel and low alloy steel. So far, whatever damage mechanism we have seen, it is start with the carbon steel, low alloy steel. That is the sequence they will start. But here it will come only stainless steel. Austenitic stainless steels are highly susceptible. Duplex stainless steels are resistant. Nickel alloys are resistant but not immune. Not immune means still there is a chance. Generally, they will not come in nickel based alloys, but still they can come. Okay. Now, which one is the resistant material? It will not come in a carbon steel and low alloy steel, it will not come. If you take a stainless steel, actually, what are the elements stainless steel have? Chromium and nickel. Nickel plays an important role in determining the cracking possibilities. For example, this 3 sentence again important. Nickel content 8 to 12%, highly susceptible for chloride stress coefficient cracking. Nickel content above 35%, highly resistant. Nickel content above 45%, nearly immune. Again, I will repeat. Nickel 8 to 12%, highly susceptible, highly possible. Above 35, highly resistant. Above 45, nearly immune. Nearly immune is very rare. It will not come. Okay. Then how the appearance will be? It can be a spider web like the same caustic, and sometimes craze crack. Craze crack means it will not follow any pattern. Then prevention, just we discussed. Generally, all stress coefficient cracking prevention method is PWC. Because it is stainless steel, PWC is generally not advisable because it can have other problems. Suppose if you want to do PWC, what I said, heat it fast, cool it fast. It is given here. Generally, we should go for a low chloride whenever you are dealing with the stainless steel. That's why hydro test. You have to use a special water. What is the maximum chlorine content allowed? Less than 50 ppm. When you do hydro test of stainless steel, the chlorine content should be less than ppm. So I think NDT people know when you are doing stainless steel PT, the chlorine content should be less than 0.1% as per section 5. So anywhere, you should not allow chlorine in contact with the stainless steel. NDT, only thing here, because stainless steel we cannot do wet fluorescent empty. So caustic and this one wet fluorescent empty is the preferred one. Here we cannot do wet fluorescent empty. Eddy current is the preferred. PT we can we can do. PT we can do it. Then same other things are acoustic emission, monitor the crack growth, all will repeat. Okay. So important is above that is 8 to 12 highly susceptible, above 35 highly resistant, above 45 nearly immune, temperature above 140 it will. These are the key points. So please take surface entity cracking on 300 series stainless steel and nickel based alloys under the combined action of tensile stress, temperature, and aqueous chloride environment. It is also referred as a chloride cracking. That is closed book question. All 300 series SS are highly susceptible. That is closed book question. Last exam also asked. B. Duplex stainless steels are more resistant but still susceptible. Nickel based alloys are highly resistant but not immune. That is open book question. That is important. Critical factors: chloride content, temperature, pH, tensile strength, presence of oxygen, and alloy composition of critical factor. That is open book question. And C, increasing levels of fluoride increase the likelihood of cracking. That is open book question. Then D1, second line, cracking usually occur metal temperature above 140 degree Fahrenheit, and experience has shown this to be useful temperature. That is very important, above 140 only. Another one, this I forgot to tell, again important. Generally, it is a acidic stress corrosion cracking. Caustic, amine is a alkali. Acidic means what is acidic? Below pH 7, but it will happen up to above 2 only. Below 2, it will not happen. The potential for cracking increase at lower pH. However, SEC usually does not occur below 2. At this lower pH, uniform percent generally predominates. That is important. Open book question. E, point number E. Then next page, H and H1 is very important. Nickel content of the alloy has a major effect on resistance. The greatest susceptibility, stainless steel with nickel content 8 to 12%. Alloys with nickel content above 35% are highly resistant, and alloy above 45% are nearly immune. Then appearance and morphology. So surface breaking cracks can occur from process side or externally under insulation. Highlight this one. A. Crack characteristic of Francesca may be many branches and may visually detect spider web or cross cracking. That is open book question. And E. Cracking of sensorate 300 may be intergranular. Highlight this one. And the prevention, material of construction resistant to chloride suspension should be used. Carbon steel, low alloy steel, and 400 series stainless steel are not susceptible to chloride suspension cracking. That is open book question. Then B. When hydro testing, low chloride content water should be used, followed by quick dry out. So you have to use a low water. This is not important, but you can see the E. Although not a standard or common refining industry practice, a suitable high temperature stress relief of 300 series after fabrication will receive the residual stress. However, consideration should be given to possible effect of sensitization that may occur, increasing the susceptibility of PTA, means polythionic acid. Stress corrosion cracking. This is not important. Inspection. VT can be used to find advanced stage. Then this is open book question. PT can be used to chloride stress corrosion cracking. However, extremely fine cracks may difficult to detect PT. Special surface preparation, polishing under high pressure. That is open book question. So we have to go for, if you are going to PT, we have to use a water blast to remove the corrosion products. Then C is important. ECT inspection method can be used on condenser tubes. That is important. Eddy current testing. Then D, angle beam UT, shear wave UT, PA from the opposite wall can be used. RT is often not sensitive to detect cracks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 question we mark. Next one is erosion corrosion. As we already have seen. Now, actually, this is three damage mechanisms. Erosion is separate, corrosion is separate, erosion corrosion is separate. Before that, what is hardness? What is hardenability? We have two different mechanics. See, hardness, hardenability, both are not same. Point number one. They are not same. What is the difference between hardness and hardenability? Hardness is a surface property. Hardenability is the entire thickness property. So the definition of hardness is resistant to indentation by plastic deformation. For example, if you are pressing a surface or you are hitting a nail, if it is not going, then it is a hard surface. Inside it may be soft also, but the surface is hard. How you will improve the hardness? By adding a carbon percentage. When you add carbon, hardness will be increased. What are the hardness tests? Brunel, Rockwell, Vickers, Knoop. There are four hardness tests. Brunel, Rockwell, Vickers, Knoop. Generally, to avoid the stress corrosion cracking problem, carbon steel should have hardness level less than 200 Brunel hardness. Now coming to hardenability. Hardenability, I told it is the entire depth. It is not only surface property. So definition of hardenability is depth of hardening by quenching. When you quench it, heat it and quench means cool it very fast. How much depth it is hardening? Hardenability cannot be improved only by carbon. It is nothing to do with the carbon. It is depends on the chromium molybdenum percentage. When you have more chromium molybdenum, it will have more hardenability. Now, what is the relation between this and the erosion corrosion? There is a relation. What is the hardenability test? That test you might have not heard about this. Germany bar test, Germany end quench test. The test is called. Now coming to back to erosion corrosion. So there are three damage mechanisms here. Erosion is separate, corrosion is separate, erosion corrosion is separate. First, what is meant by erosion? What is erosion? Erosion means the removal of material by force. The last season when there was a flooding, some 6 months back, everybody watched the video. Kerala, one house is eroding. பார்த்தீங்களா ஒரு வீடு இது போச்சு ஒரு ஹவுஸே போச்சு. That is a erosion. Any force will erode, flood, or even what you called the storm. So erosion. Where you can expect the erosion in a piping? Piping, where erosion will be there? Elbow. Wherever there is elbow, flow direction change. If it is having high velocity and inside some solid particle mix up, then the elbow will have a erosion problem. That's why to avoid erosion, suppose you think there is a severe erosion is there, they will go for a long radius elbow. Because short radius will be short turn, long radius will be smooth turn. So erosion in piping can be on the elbow, particularly. Pressure vessels opposite to the inlet. Storage tank opposite to the inlet. So what they are doing in pressure vessel, they will put a plate that is called the impeachment plate. So that when it's eroded, it will remove and replace within the plate. Storage tank, they are using one thing called a diffuser. It will not directly hit it. They will spread it. Now, how to avoid the erosion? If you know erosion, piping, how to avoid the erosion, you can increase the diameter, use a long radius elbows, or increase the surface hardness. If the surface is hard, it will not erode. A simple example is, wherever in our villages, if we see some pump set, where the water is falling, they will put a stone there. Because it will erode the soil. பார்த்தீங்களா பள்ளம் தோணும். ஆனால் என்னன்னா ஒரு கல்லு போட்டு வச்சிருப்பாங்க. It will erode the soil because of the force. So to avoid erosion, we have to increase the surface hardness. So we can go for a surface hardening treatment, or if it is not hardenable, you have to increase the thickness. to compensate for the erosion. That is separate. Coming to the corrosion, corrosion is the electrochemical reaction. So it is due to the chemical. How to protect from the corrosion? How will protect a piping from the corrosion? Coating, simple painting coating. That's all. Now the next one is erosion corrosion. When they combine together, they will have more effect because erosion will help the corrosion. For example, you think only corrosion and you painted it. When erosion is there, what will happen? Erosion will remove the paint. Then it will be exposed to the corrosion. That is called erosion corrosion. So how to prevent from the erosion corrosion? We have to go for hardenable alloy. That's why I told hardenable. We have to change the material or we have to alter the process. We have to change the design. That's all erosion corrosion. Which material it will affect? It will affect all materials. It is not a material dependent. Even particularly in vessels, refractory lining is inside there. It can erode. It is removed. The vessel will be heated up. That is called hot spot. Infrared thermography is the NDT method to detect the hot spot. Then how the appearance will be? It can be many appearance. It can be small pit, groove, gullies means large holes or you can holes. How to prevent it? I already told you. Which NDT will detect? If it is a vessel or tank, we can see inside. Piping, you have to go for radiography or ultrasonic. Thermography can be used for the refractory loss. Refractory loss we can detect from the thermography. That's all. One of the another important type of equipment. Please take. Erosion is a mechanical removal of surface material as a result of relative movement between impact from solid, liquid, vapor, or any combination of thereof. It is typically found in surface where solids are entertained in liquid or vapor streams such as slurries and fluidized solids. That is important. Then 2 is important. Erosion corrosion is the description of damage that occur when particle erosion and high velocity contributes to corrosion by removing protective films or scales or otherwise accelerating corrosion rate. This is also called velocity assisted corrosion. That is also closed book question. Critical factor, highlight the 2. Increasing the hardness of the eroding metal component can reduce the rate of erosion damage. However, this may not be effective where corrosion plays a significant role. Then last line, open book question, same first this page. Increasing the pipe thickness will decrease the ID. So when you see pipe, it is a OD is constant. When you increase the thickness, ID will be reduced. So there will be more pressure actually. And increase the velocity, potentially increasing the corrosion rate. Open book question. Then affected units. Highlight this one, open book. All types of equipment exposed to moving fluids and catalysts are subject to erosion and erosion corrosion. This include piping bends, elbows, T, reducer system, downstream of let down valves, pump blower. Wherever a sudden opening, any closed valve suddenly open, there is a possibility of erosion. Open book question. Appearance. Erosion and erosion corrosion are typically characterized by localized and thickness in the form of grooves, gullies, waves, rounded holes, valleys, and simply greater amount of thinning. That is important. Then B, in liquid lines containing particulate low velocity, that is around 5 foot-pounds, can allow solids to tumble at the bottom and cause in the 6 o'clock position. So if the velocity low 6 o'clock position bottom, there will be erosion corrosion problem. That is open book question. Prevention, changes in shape, geometry, and material can mitigate the erosion and erosion corrosion. Example include increasing the diameter to reduce velocity, streamlining bends, and using replaceable impeachment purpose. The next B, improve resistance to mechanical erosion is usually achieved by increasing the hardness. That is important. Using the harder alloy, hard facing, and the surface hardening. If it is only erosion, then this is another important. Erosion corrosion is best mitigated by using more corrosion resistant alloys and or altering the process environment to reduce the corrosivity or deaeration or dissolve. This is closed book question. Then these are not important. Highlight the F. Infrared thermography scans can be used on stream to detect refractory degradation. That is important. Closed book question. The next page, you can see the erosion corrosion rates in seawater. So sometimes there was a open book question. So if you take 1 foot-pounds tidal current, what will be the corrosion rate? These are the corrosion rate. And you can see titanium is not affected by erosion corrosion. Just to highlight this one, it was asked in one of the old exam question, which are the following material not affected by erosion corrosion in seawater service? Answer is titanium. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 questions. Next one is hydrochloric acid corrosion. Just 2 minutes, I'm coming. Hold பிடிச்சிட்டு போக மாட்டேங்குது. Okay, so please take hydrochloric acid first. Now, what is hydrochloric acid? One is missing. So hydrochloric acid is an acid. So the pH will be less than 7. Hydrochloric acid corrosion, dew point corrosion, both are same damage mechanisms. So before there are 2 separate damage mechanisms, but the principle is same. When the hydrogen chloride mixed with the water. So when hydrogen chloride mixed with water, it will form the hydrochloric acid. Now, hydrochloric acid will affect all materials. But which material is resistant? Nickel-based alloys and titanium. They are the resistant materials. It will affect all materials. Now, where we are, how to avoid the hydrochloric acid corrosion? Wherever it is not necessary, we have to add caustic. We have to neutralize. These are some of the key points. So please take hydrochloric acid causes both general and localized corrosion and is very aggressive in most common material of construction across a wide range of concentrations. Damage in refineries is most often associated with dew point corrosion, in which vapor containing water and hydrogen chloride contents from overhead steam, a distillation, fractionation, and stripping. See, last exam, they asked a question without mentioning the hydrochloric acid corrosion. They asked, the question was, which of the following damage mechanism will occur in the overhead stream of distillation, fractionation, or stripping tower, like that. So we have to search it. It is an open book question. It is hydrochloric acid corrosion. See, when they asking question like this, how to search it? They are given 4 options. Each and every option you have to go and search it. For example, option A, hydrochloric acid corrosion. Option B, sour water corrosion. Option C, so no need to check entire book. Only the 4 options, any one of the damage mechanism we have to search. Okay. All common materials are in refineries, acetyl acid concentration, temperature, and alloy composition. Then D is important. Carbon steel and alloy steels are subject to excessive corrosion when exposed to any concentration of acetyl acid, pH below 4.5. That is important. Then F is another important open book question. Alloy 400, titanium, and some other nickel-based alloys have good resistance to dilute HCl in many refinery applications. Then appearance. This is an open book question. Carbon steel and low alloy steel uniform thinning, localized corrosion under deposit attacks. 300 series and 400 steel often fitting attack. 300 experience chloride suspension cracking. If the temperature is high, means more than 140. Open book question. Prevention. Optimizing the crude oil tank, water separation, withdrawal under this one. This is open book. A common target is 20 ppm or fewer chlorides in the overhead accumulator water. So we have to reduce the chlorine concentration. Hydrochloric to avoid the hydrochloric acid. Then we can add caustic. Caustic injection downstream of the desalter is another common method to reduce the amount of HCl. That is open book question. Then NDT, if you go next page, strategically placed corrosion probes and our corrosion coupons can provide additional information. So you can use your corrosion probes or corrosion coupons. That is again open book question. Now we will go to the next damage mechanism, mechanical fatigue. So what is fatigue cracks? Due to cyclic loading, again fatigue cracks are surface cracks. The only difference between stress corrosion cracks and fatigue cracks, both are surface, but stress corrosion cracks, PT is not preferred, I told you. The reason is there will be a corrosion product blocking the crack, but the fatigue crack, there will be no corrosion product. So we can do PT also. PT, MT, both is possible. Now, cyclic loading, I told the fluctuation in temperature, pressure, or vibration. But here we are concentrating only the mechanical fatigue means fluctuation in the pressure. If it is excessively fluctuating, it will crack below the yield strength. You remember I told what is yield strength? What is tensile strength? What is yield strength? Below yield strength, the material will be elastic. Above yield strength, it becomes plastic. Generally, material will not fail below yield strength. But when it is in cyclic service, it will fail below yield strength. Suppose you give the minimum load less than yield strength, some material will not fail. That load limit is called as a endurance limit. There is another word, technical. Endurance limit. What is the endurance limit? Below this load, fatigue crack will not fail. So carbon steel, okay, titanium, sorry, nickel-based alloy, they have the endurance limit, but the stainless steel don't have endurance limit. 1 million to 10 million cycles, they will have the fatigue crack problems. Now, it will affect all materials. Fatigue crack will also affect all materials. How the appearance will be? So that is actually regularly asked exam question. Fatigue cracks start from a surface notch. So the design is the most important critical factor for design. Means surface notch means a weld undercut, a ripple in the weld, a arc strike, a tool mark, a grinding mark, a drilled hole. These are the surface notches. So if it is start from one surface notch, actually to start the crack, it requires more cycles. But once the crack is started, the crack growth is unknown. It was asked in the one of the exam. Fatigue crack growth, answer is unknown. We cannot predict when it will fail. So how the single surface, it will look like this. The fractured surface will have lines like this. These are called clamshell. What is meant by clamshell? The seashore muttu sippimamla, pearl, that one. You can see the lines. That is a clamshell. If you have a multiple surface notches, this clamshell marks will overlap. These are called beach marks. So how the beach, in beach, the sand have a line marks. Suppose there is a notches in different directions. Here also they will have a marking. These are called ratchet marks. So please copy this. So a fatigue failure can be characterized by a clamshell when they have a single notch. Multiple notch will have a beach marks. A different direction will have a ratchet marks. Now, you remember I told you a heat treatment, there is one thing called a normalizing. What is normalizing? Heat it, cool it fast to improve the toughness. Normalizing improve fatigue resistance also. Now, how to appearance, I already told. How to prevent the fatigue cracks? Design. Design is the key. You should not have any surface notches. Or we can go for heat treatment to improve the toughness, will improve the fatigue resistance. Then NDT, you can do PT, MT. Even if you want inside fatigue crack, outside, we can go for a UT also. Okay, so please take, this is another one of the important damage mechanism, fatigue cracks. Fatigue crack result in a mechanic form of degradation that occurs when a component is exposed to cyclic stresses for an extended period from dynamic loading due to vibration, water hammer, unstable fluid flow, often resulting sudden unexpected failure. That line is important. Close book question. Then B, these stresses can arise either from mechanical and thermal cycling and are typically well below the yield strength of material. That is close book question. Below yield strength, it will happen. So it will affect all materials, though no important. Then highlight this one, A, geometry, stress level, number of cycles, and the material properties, strength, hardness are a predominant factor. Then design factor, fatigue cracks usually initiate on the surface at notcher or stress risers under cyclic loading. For this reason, design of a component is the most important factor in determining the component resistant to fatigue cracking. Design is the key. So design means, so what are the stress conditions? Keyhole, mechanical notches, weld joint flaws, tool marks, grinding marks. These are asked in various exams. Lip on drilled holes, root notches, corrosion. These are the reasons fatigue cracking can have. Then metallurgical issue, last slide, same page. Some materials such as titanium, carbon steel, and low alloy steel have an endurance limit. In such cases, the number of cycles to fatigue fracture increases with the decreasing stress amplitude until the endurance limit is reached, below which fatigue cracking will not occur regardless of the number of cycles. So below endurance limit, fatigue cracking will not occur in carbon steel and titanium. Then 300 series, 400 series SS, aluminum, and most other non-ferrous have fatigue characteristic that does not exhibit an endurance limit. And highlight this next line. Maximum cyclic stresses for design selected to determine the cyclic stresses typically 10 to the power 6 to 10 to the power 7 cycles. Stainless steel, there is no endurance limit. And this is important. 6. Heat treatment can have an effect on fatigue resistance of a metal. In general, fine grained microstructure tend to perform better than the coarse grained. Heat treatment such as quenching and tempering can improve the fatigue resistance. Then where the vibration problem will come, highlight the A, affected units. Socket weld and small bore piping associated with or near pumps, compressor or other rotating equipment that are not properly gusseted or supported will have the vibration fatigue. Then highlight the 343.5A. Damage is usually in the form of crack emanating from a point of high stress concentration or other corner of key shaft. Then these three are very important. I altered the signature mark of fatigue failure is a clamshell type fingerprint that has concentric rings called beach marks emanating from the crack initiation site. That is important. Close book question. Crack nucleating from surface stress concentration or defect will typically result in a single clamshell. Only one defect, single clamshell. And C, crack resulting from over stresses of a common without one significant isolated stress concentration will typically fatigue failure multiple points. These multiple sites often called ratchet markings. Prevention. The best defense at fatigue cracking is a good design. That is important. That help to minimize stress concentration in the cyclic service. That is important. Then highlight the 7. Minimize the weld defect as this can accelerate fatigue cracking. Minimize grinding mark, fix gouges, or use low stress terms. Then inspection next page. PT can be used to detect cracks open to surface. MT can be used to detect cracks open to surface or near surface. Angle beam, shear wave UT or PAUT can be used to detect fatigue cracks at known or suspected area. That is important. That is close book. The next one is MIC, microbiologically influenced corrosion. So what is MIC? Page number 238. See, a water is flowing or a water is stagnant. Which will corrode more? Stagnant water. So MIC is caused by the stagnant water. So where a water will be stagnant, generally it is a storage tank bottom. There will be a water phase, or in heat exchanger if the velocity is very low. This problem will come. This is due to the living organism. Living organism means bacteria, fungus, algae. Algae and the பூசரம் பிடிக்குதுங்கறமா. Due to that, that is called MIC. Microbiologically influenced corrosion. Now, for MIC, generally what we will say, all living organisms need light and oxygen. That is not required actually. For MIC corrosion, it can no light, it is total darkness, no oxygen, still this corrosion will happen. But they need sulfur, phosphorus, nitrogen for growth. Here also there is a nickname. How the corrosion will look like a pit, pitting, a big pit inside another pit, a pit within a pit. That is the specialty of the MIC. A cup-shaped pit within a pit, or sometime it will be under deposit attack. Under deposit means any corrosion product inside there will be a corrosion. Deposit, chemical deposit inside there will be a corrosion. Now, how to avoid MSC? So what you have to use a water treatment by adding chlorine. Water you can add to kill the bacteria. Chlorine, bromine, or you can use the ultraviolet. You can use it, but they may give only temporary effect. It is a not long-term effect. Storage and inside, sometimes they are using catalytic protection. Generally, catalytic protection they are using the soil side. Inside also, to reduce this MIC, they can go for a catalytic protection. Okay. NDT wise water analysis. So you have to take the sample and check this microbe content, and a bad smell of water indicates a corrosion. A foul smell, bad smell water coming means corrosion is happening inside. These are the key points. Another important damage mechanism. So please highlight this one. Corrosion caused by living organisms such as bacteria, algae, and fungi. It is often associated with the presence of tubercles or slimy organic substances. Often the bacteria produce localized corrosion in the form of pitting or crevice corrosion. Close book question. Affected most common material of construction including carbon 300 all. This is open book question. Titanium highly resistant. Then critical factors, highlight the B. Because there are many types, organisms can survive and grow under the wide range of conditions including lack of oxygen, light or dark, high salinity, pH 0 to 12 and temperature 0 to 35. And this is important. D, second line. In addition, all organisms require source of carbon, nitrogen and phosphorus for growth. Then affected units, highlight this one. MIC is often found in water-cooled heat exchanger, bottom water layer of storage tank, and piping stagnant or low flow and piping in contact with some soil. The next page, appearance. These two are important. MIC corrosion is frequently observed as a localized pitting and a deposit or tubercles that shield the organism. So pitting and a deposit, that is important. Damage is often characterized a cup-shaped pit within a pit or the hollow effect in carbon or subsurface cavities in stainless steel. Prevention, microbes require water to thrive. System that contain water should be treated with the biocides such as chlorine, bromine, ozone, ultraviolet, and other proprietary compounds. Then highlight the B. Proper application of biocides will control but not eliminate microbes. Therefore, continuous treatment is often necessary. Then H is very important. Coating and catheterically protecting underground structure and interior of storage tank bottom have been shown to be effective mitigation methods for MIC. That is a open book question. H. Inspection. A. In cooling water system, effectiveness of treatment is monitored by measuring biocide residual, microbe counts, and visual appearance of water. Sampling and analysis can be performed by a test, so we have to take the sample. Then D, foul smelling water may indicate biological activity. Foul smell indicates the biological activity. So this is the cup-shaped pit. You can see here a big pit. Inside there is another small pit. So next one is sour water corrosion. Right, page number 297. So what is sour water corrosion? Okay, now water pH is 7. Suppose when the water dissolved with the H2S, it will become acidic water. So the pH will be less than 7. That is called sour water because it is highly corrosive. So normal water pH 7, that is also corrosive, but it is more corrosive than the normal water. Sour water, the pH range is 4.5 to 7 because it is dissolved with the H2S. When H2S dissolve, this sulfur, H2S has sulfur, react with the iron and form iron sulfide. See, what is the corrosion is actually iron oxide. If the iron sulfide layer is formed, corrosion rate will reduce. It will protect from the corrosion. But the iron sulfur rate is a thick layer form. It will have pores inside, so it can cause a pitting corrosion. Okay, generally it will affect carbon steel only. Generally, stainless steel, other metals are usually resistant. Now, store water corrosion also, how to monitor is water sample analysis only, or you can use a corrosion probes and a corrosion coupons. Not a very important damage mechanism. So please take corrosion of steel due to acidic sour water H2S 4.5 to 7. That is the keyword. So what is the pH range? It will happen 4.5 to 7. Mark it. Open the question. Then primarily affect carbon steel, stainless steel, copper alloys, and nickel-based alloys are usually resistant. That is open the question. H2S content, pH, temperature, oxygen concentration, all critical factor. C, at a given pressure, H2S concentration in the sour water decreases with the increased temperature increases. That is open the question. E, above a pH above 4.5, protective thin iron sulfide layer helps to limit the corrosion rate. That is open the question. In some instances, pH above 4.5, thicker porous sulfide film layer can form. This can promote pitting under the sulfur deposits. Appearance, corrosion damage from acidic sour water, typically general thinning. However, localized corrosion or localized under deposit attack can occur, especially if air or oxygen is present. 300 series successful to pitting attack and may experience a crevice corrosion and chloride suppression. That is open book. Prevention, process monitoring and control are important for minimizing the effect of sour water corrosion. Process parameters, so we have to monitor H2S, pH, all these things. That is open book question. 300 series can be used at temperature below 140 where chloride suppression cracking is not likely. That is again open book. Inspection, UT scanning, RT can identify locally thinned areas. Then strategically placed continuous corrosion monitoring, corrosion probes and corrosion coupons we can use. That is also open. Then finally, sulfidation, the last damage mechanism. This is another important damage mechanism. First one, what is sulfidation? Sulfidation is a uniform corrosion caused by when sulfur with carbon steel or low alloy steel temperature above 500 degrees Fahrenheit. So for sulfidation to happen, it will happen only in carbon steel and low alloy steel. Even alloy 400 series and 300 series are resistant active. Okay. Now, what is the temperature I told you? Above 500. It will be uniform corrosion. Now, the resistant metal is the chromium. When you increase the chromium, it will more resistant. Okay, that's why if you see sulfidation have special NDT, you have to find out the chromium level. So which NDT will find out the chromium level? PMI is the NDT for sulfidation. Okay, now another one is the older piping. Before they used to make pipe in A53 grade B. Now we are using generally what? A106 grade B. What is the difference between A53 grade B and A106 grade B is 106 grade B have more silicon. When the silicon content is more silicon means more than 0.1%, sulfidation will be less. Older steel will have more sulfidation problem. Then how to prevent it? I told you we have to increase the chromium content. So these are the key things. So please take corrosion of carbon steel and other alloys reaction with the sulfur compound in high temperature. The third line is important. This mechanism also known as sulfidic corrosion. That is important. Close open to question. Then affected materials, all iron-based material, including carbon steel and low alloy steel, 400 series and 300 in that order from most susceptible. So carbon steel is most acceptable, 300 series less susceptible because of the more chromium content. Then B, nickel-based alloys are also affected by varying depend on the composition, especially chromium content. See, nickel there is no use. If you increase the nickel, it will not this one. Then major factor sulfidation, chemical composition, temperature and concentration. Then B, first line is very important, close book question. In general, the resistance to iron-based alloys are nickel determined by the chromium content of the material. Increasing the chromium content significantly increase the resistance to sulfidation. So only chromium. And the fourth line, nickel-based alloys are similar to stainless steel in that similar level of chromium provides similar resistance to sulfidation. However, nickel alloys with little or no chromium, poor resistance. So only chromium will decide, not nickel. That is open to question. Then D, I told you, the silicon content of carbon steel can significantly affect the success of sulfidation. Carbon steel with silicon content less than 0.1% have been found to suffer variable and high sulfidation. Example, they are given this sixth line, you can see. There are a number of incidents. Lower silicon ASTM 53 pipe suffered significantly more metal loss than A106 pipe. The next one is another very important. F. Sulfidation of iron-based alloys begin metal temperature above 450, but normally only become practical concern above 500. Then appearance, depending on the service condition, corrosion is most often in the form of uniform thinning. And can also occur localized high velocity erosion corrosion. Generally, it will be uniform thinning. Prevention, resistant to sulfidation generally achieved upgrading to higher chromium alloy steel such as 9 chromium. That is important. That's all. Inspection, highlight this one. Proactive and retroactive material verification program can be used for alloy verification to check alloy mix-ups where sulfidation is anticipated. That is close book question. Now, there is a graph here. Sometimes there may be a question from this graph. So how to answer this? You can see here, carbon steel 1 to 3 chromium, 4 to 6, 7 like this. So if the temperature is 600 degree Fahrenheit, say chromium is 9 chromium, what will be the corrosion rate? So we have to match like this. So 600 degree, 9 chromium, for example. So where it is coming, it is 1, 2, 3, 4 like this. So between 2 and 3, it is a 2.5 mils per year. You can see the uniform is, it is a mils per year, not a uniform scale, 0.01 here. Then 0.1, 0.2, 0.3, 1, 2, 3, 10, 20, 30, 100 like this. Okay, so suppose you look at, for example, 700 degree, 12 chromium. What will be the corrosion rate? You have to match here. So the line will match here. This is 1.5. So it is not going to holding 1.5 lines. That's all 571. So as I said, it is not a tough code book. Actually, it is a tough code book. It's not an easy code book. Okay, so we have another 30 minutes. So what we will do, afternoon we will review the question B31.3. So I will start introduction to 570. So tomorrow is a 570. Just half an hour. Just to listen it. Introduction to 570 will start. Thus, understanding is the important. 570 is the most important code. I will just take introduction class tomorrow morning. So afternoon, as I said, B31.3 we will review today. Let him come just for 2 minutes. So what is 570 code is? This is a definition of 570. So in service inspection, rating, repair, and alteration of piping systems. Just 1 minute, please. So this code book you should understand properly, because this is the key to pass the exam. 570 is the, as I said before, we will not complete in 1 day. It may take more than 2 days actually. It may take 3 days also. So, first one, it is a code. Code means it is a legal document. We have to strictly follow. So if you agreed to do the inspection as per 570, you have to strictly follow. You cannot deviate it. Second one, it talk about the in-service inspection. Now, what is in-service? So a pipe in operation is in service. Okay, suppose piping in shutdown. It is in service or not in service? It is still considered in service. It can be shut down for many years. When which pipe is not considered in service? Only 3 pipes. A piping not started operation, not in service. A piping retired from the service. Retired from you are removed from the service. Third one is abandoned pipe. Abandoned means they are in the location, but we have no intention for future use. We are not going to use it again. Just we kept it, leave it like this. It's properly isolated, but we are not going to use it. That is called abandoned pipe. So the common example, if we travel through highways, we can see some abandoned vehicle on the roadside. Because it is severely damaged, what my people left there itself. That is called abandoned. So abandoned piping is not covered. Retired piping is not covered. Piping not installed means operation not started is not covered. Other things will be covered. Now, mothballed means it is covered. It's covered. Okay. Then, what are the different type of inspection we have? We have internal inspection, external inspection, on-stream inspection, thickness measurement. Then we have what you call the CUI inspection. So we have some 6-7 types of. We have deadlock inspection. Okay, this one. Now, what is meant by rating, repair, and alteration? Rating or re-rating. Rating means gender terminology. Or rating or derating. So, you know what is our Barlow formula? What is the Barlow formula? T is equal to PD by 2SC. Suppose a pipe is serviced for many years, say 20-25 years. You are now measuring the thickness. The thickness become less than the minimum required thickness. So it is gone below the minimum required thickness. Then what I have the option? One of the option is I can cut it and repair it. Use another pipe. Replacement I can go, or I can retire it. No, I will remove this. I will use another one. Another option is service change. I can use the pipe, but I will change it to another service. And one more option is re-rating. Re-rating means, you know the Barlow formula, T is equal to PD. If you reduce the pressure, the thickness also can be reduced. So in the same service, instead of operating original pressure, I will reduce the pressure and operate. That is called as a re-rating. Now, next one is what is meant by repair, what is meant by alteration. So there are 3 terminologies. These are, please listen. If you don't understand, please ask questions. Repair, major repair, alteration. Repair means you are going for inspection, you find some defect, you grind it and weld it. That is repair. Major repair means you find a severe, some portion of the pipe is damaged, you want to cut and replace with a new pipe. That is a major repair. Cutting a section of piping and replacing. Alteration means any design affected because of this repair, then it is alteration. A simple example, if you are cutting a 6-inch pipe and replace with the 8-inch diameter or 4-inch diameter pipe, then it is become an alteration. When the pipe diameter changes, it become alteration. Design changes, it will become alteration. You understand this? Now, how the 570 works? So the overall responsibility for implementing the 570 is the owner user. So he is their overall responsibility. Everywhere we will use owner, user. So what is the difference between owner and user is owner is the owner of the piping. User is he is not the owner, but he is responsible for everything. He is under lease or some contract he is using the pipe. But a owner user cannot do the all inspection activities at 570. So what he will do, he will appoint a authorized inspection agency. So he will appoint a authorized inspection agency for inspection purpose. It can be inspection department of the owner himself. So he can have a department, or he can hire from a third party. He can appoint a third party or hire from an insurance company or hire from a local government. That is authorized inspection agency. Authorized inspection agency will appoint a authorized inspector. So if you become, when you become an authorized inspector, he will work in a authorized inspection agency. This is the inspection. Now, who will do the repair? Inspection agency, they will just inspect whatever the problem they will tell. They will not do the repair. So all repair will be done by another organization that is called as a repair organization. So who will do the repair organization? This one, repair organization. Then suppose you want some modification. Who will design that one? Then we need a piping engineer. Need a piping engineer. Then NDT. Who will do the NDT? All NDT will come under the NDE examiner. Examiner means technician. Okay, actually the ND examiner, even he will directly report the owner user, he will work under the inspector only. Inspector only, he will report to the inspector, but his contract will be direct with the owner user. There is one more person as a concern, he is not part of the team, he is a corrosion specialist. So this is the organization, how the 570 works. So overall responsibility, owner user. For inspection purpose, he will, what happened? Yes, you were the director. Okay. Okay. Inspection purpose, he will appoint authorization. Please understand these basics are very, very important. So no need to write anything, just listen because tomorrow only we are going to start the class. So authorized inspection agency. So the authorized inspection agency will do inspection through inspectors. They will appoint the inspector, they will choose. Then apart from the physical work, repair work done by the repair organization, then for design purpose, we need a piping, design stress analysis. So we need another engineer knowledge person, that is a piping engineer. Then NDT will be conducted by the ND examiner, ND organization. They actually all report to one another. Actually, ND examiner under the he will work under the AP inspector, but he will report anything so contractor, he will report to the one another. This is the organization chart. Is it clear? If you want, write this copy. Corrosion specialist is an independent person. He will be consulted by the, so you can mark a draft. So here, so he inspector, whenever he has a doubt, he is not part of the team. Whenever inspector have some doubt about the corrosion, he will consult a corrosion specialist. That's all. So part of the team is, see, if the exam they will ask, who will implement 570? Only these 5 people. 1, 2, 3, 4. These 5 people will make a team. This team only responsible for the 570. Owner is overall responsibility. Corrosion specialist is a consultant. Whenever inspector have some doubt, he will consult it. Right. Now, actually how it works. So we have different type of inspection. I told you internal inspection is not normally conducted on piping. Next one inspection, what I said, external inspection. External inspection means we will check the outside condition of the piping completely. Third one is called as a on-stream inspection. What is on-stream? Checking the inside condition from outside by using RT or UT. Now the problem is on-stream we cannot check complete piping. It is practically not possible. Complete doing UT or RT is not practically possible. So what we will do, suppose I have a pipe like this. So a pipe is going like this. Now a pipe is going like this. First, I will divide the entire piping into groups. These groups are called as a, so I will write like this. Your piping will be grouped into piping circuit. So the grouping circuit based on the piping circuit have same design, same material, same damage mechanism. It is based on the P and ID. What is P and ID? Piping or process and instrumentation diagram. This many circuits will combine and form a piping system. Piping system based on the PFD, process flow diagram. Many system will make a piping unit, and many unit will have a process plant. So this is how it works. Our inspection point of view, these two are important. Others is not part of our inspection. So we will make circuits. Sometimes we will make a system. Now, suppose this is my circuit. Circuit also, entire circuit, we cannot do this one. Some selective area only we will do NDT. These selective areas are called as a CML. CML means condition monitoring locations. So in CML, we can do any entity. It is not restricted only RTUT. We can do, suppose we have served out a fatigue crack. Fatigue crack, what we will do? PTM. Okay, so any type, what type of damage mechanism, wherever, see how they will mark CML based on their previous experience. But every time when they are going for inspection, based on the current condition, they can change the CML. It is like our CV. Every time after doing some 1 year, every year we are revising our biodata based on our experience. Same way, it is a CML works. So CML, and the CML will have examination points. Now, if you take circuit, I told what is the common thing? Same material, same damage mechanism, same design condition. But even within a circuit, some portion can corrode differently. This can have a accelerated or more portion. What are this area is called as a, one is called as a dead leg. It is within a circuit, but it can have a different portion, right? So we have to monitor separately. Second one is called as a injection circuit. Injection point or injection. Third one is called as a mixing point. Fourth one is called as a soil to air interface. So these areas are within a circuit, but may have a different correction rate because of the erosion or other problems. So we will see everything deeply tomorrow. Tomorrow morning, so afternoon we'll have a B31 review. If you want just to copy this one, just to copy this. This is the organization how it works. Piping circuit,